Good everyone, and welcome to the fifth day of workshop on PLS SEM using R. Okay, so let us begin. And today we have only 6 people. You can just visualize or analyze that as the day progress and we move from basics to advanced, the number of participants and their participation start dwindling. So this is what I have experienced, and on the very first day itself, I told on the very first day we were 19, including myself, and now today we are just 7, and Tushar joining late. Okay, welcome. By the way, today and tomorrow we will be taking all advanced issues in PLS SEM. So yesterday I think we left and we did not test model comparison. So today we are going to talk about model comparison. Yes, Tushar, just mute yourself, Tushar. Tushar, mute yourself. Okay, so we'll take model comparison today, and after that we'll see multi-group analysis, which is again a special case of moderator. Okay, and today we'll take higher order models. I think Professor Love was talking about that I should cover higher order models. Of course, that is there in the agenda. So we'll definitely talk about higher order models, and today we'll test a very complex model. Yes, on which I am working for my second paper. Yes, okay. And tomorrow we'll take all advanced issues in PLS SEM, particularly this results robustness checks. Okay.
Sir,
And yes, Love, go ahead. Yes.
yes, sir. My request is, sir, if you feel like, sir, just working on primary data, we should, if you give certain example and secondary analysis, sir, that will be really helpful for me, because I have done my entire work on the secondary analysis,
Yes.
secondary data analysis. So if the PLS SEM is very worthy and workful for secondary data analysis, I can lead the research in a good manner.
See, okay, Dr. Lavji, I got you. You have been telling about secondary data right from session 1. So, Dr. Lavji, you share the secondary data with me. Let me go through it. What is the nature of the secondary data? Because see, normally any modeling software, particularly CBSEM or let's say PLS SEM, they are designed to take care of latent constructs. So when if there are no constructs in the, let's say, in the secondary data, then slightly using smart PLS, or for that matter AMOS, would be trickier. Again, the speciality of modeling softwares are that they work with latent constructs. They work with empirical data, but it's okay that if you can identify few items and make it a construct, and then you want to understand the association of one construct with the other, then algorithms can work that way. By the way, there are a lot many organizations like CSO, Central Statistics Office, or NHFS, National Health Family Survey, or NSSO. They come out with secondary data. But there, if you focus on the secondary data, though I've not seen it and I'm not the authority to comment on it, but if you see those data, they are mostly, if you take every column, so every column is a univariate data. So maybe every column stands for something. So there, if you can club for 4 or 5 variables, and then you say, okay, these 5 variables are measuring this, then in that case, okay, secondary data is particularly fine. Okay, so but rather I would suggest download few papers where people have used secondary data for performing partially square path modeling. That would be fine. But Dr. Lavji, to answer you, you share the file with me. Let me go through it and let me give you my comment whether this could be brought into the PLS algorithm. Yes. Okay.
Definitely, sir. But
Uh,
sir, to finding out the research, even somebody has conducted a secondary data analysis
uh,
research paper in any published work on with PLS SAM. It was
hmm.
very difficult. Even I have gone through my this
Okay.
library, university library, as
Uh,
well as my own institution library. But I couldn't find this paper, any secondary data
yeah,
analysis.
that itself tells that
Yes, sir.
empirical data or primary data is more popular than secondary data. But
Yes, sir.
again, it depends upon the nature of the data. Yes, okay. So we'll definitely see. Maybe this workshop is not designed to look after secondary data,
Yes,
but
sir.
even if this workshop gets over, definitely we'll be in contact and we'll be in touch, and we'll see that how we can help you in a better way. Yes, okay. Yeah, okay. Okay, so let's start. Let's start. Let me share my screen. And today we have all advanced topic, and today we will be continuing till 9:30. Yes, okay. So by the way, friends, I have shared few more materials with you. So if you go to this practice data set, now I have given one more data which is named as ddata, ddata.csv. Actually, this is my PhD data. Okay. Yes. So I've given some part of it. And then in R syntax, if you open the R syntax, here I have given you two extra files. One is model comparison and second is higher order models. So definitely we are going to focus on these things. So today will be a very tiresome day. And today I'm going to show you some advanced modeling. Okay, how to handle models which are very, very complex, for which PLS SEM is a very preferred option for handling complex modeling. Okay. So now let me take you to my R studio. Hope my screen is visible to all of you and recording is on. Okay. Yes. Okay. Can anybody answer? Is the recording on? Yeah,
Yes, sir.
recording is on. Yes. Okay.
Yes.
So now let's focus on. By the way, I have also uploaded the day two syntax revised one. I have deleted the earlier file and uploaded the revised one. So yesterday we started with this SIC and purchase intention model. Yes, it was a marketing model and we tested a parallel mediation. We tested the parallel mediation. So all this model we definitely tested it, and we also performed redundancy analysis for formative measurements. When I say redundancy analysis, it's a technique for measuring convergent validity for formative constructs. Now, whenever you are measuring formative constructs in the survey itself, you should ask one question which should essentially capture the meaning of all the multi-item constructs. So let's say you are measuring a construct using formative indicators and there are multi-items. So apart from that multi-items, you should ask one question which exactly captures the tone and essence of the multi-item construct. And then you need to find a correlation between the global item and the multi-item. And if the correlation is above, let's say 0.70, we say, yes, convergent validity is established in formative constructs. Okay, and that is known as redundancy analysis. So we saw that. Then we bootstrap the model and then we also assess the specific indirect effects. So in yesterday's model, there were two mediators. One was PL, perceived likeness, and the second was perceived quality. And we tested the mediation of both the constructs and we tested which one is significant and which one is not significant. I think the perceived quality one was significant and perceived liking was not significant. Then we also tested the model's predictive validity or model's predictive validity, or which is also known as predictive relevance of the model. Now there is a special function in PLS SEM which is known as predict PLS. Even in smart PLS, this option is there. So you try to estimate the predictive relevance of your model for future observations. Normally, R square people say it is a measure of in sample prediction. It doesn't talk about out sample prediction. So in order to estimate whether your model will do better in case data is collected in future for the same constructs or for the same model. So there is one option which is known as PLSpredict, and it divides your data into two parts. So one part is known as training sample and the other part is known as holdout sample. So in the training sample, the model is estimated and the predictive power of the model is tested on the holdout sample. This is what we saw, and basically we focus on the RMSE. RMSE. So there is a PLS model and there is a linear benchmark model. So we compare PLS model with LM model. If the errors, particularly RMSE, if the RMSE values of PLS model are lesser than the LM model, we say that our model has a decent predictive ability. So this is what we saw yesterday. And yesterday we also saw moderation. So we focused on two important issues in SEM. One is mediation and one is moderation. So mediation and moderation, these are very important factor or important part in the SEM analysis. Okay, so mediation and moderation is tested in the presence of a new construct. So let's say if a new construct comes, what happens to the existing relationship? Okay, so mediation talks about the underlying process, yes, or it talks about the underlying mechanism, and moderation talks about the boundary condition. When I say boundary condition, under the presence of moderator, the relationship will either become stronger, weaker, or it will become positive or negative. So moderation essentially tests the boundary condition. Now I have slightly changed line number 135. I have slightly changed it because today I want to show you model comparison. I want to show you model comparison. So yesterday, if you focus on the syntax or if you see the video that has been uploaded, so yesterday we took perceived likeness as the moderator in the relationship of SIC and PI. Yes. So yesterday when we were testing it, so we conceptualized perceived likeness as the moderator in the relationship of SIC and PI. So now what I have done, I have slightly changed it and I have created a new interaction term. Now I am testing uh, uh, the moderation of PQ. Let's say if you pursue that the product quality is of decent one. So does product quality moderate the relationship between SIC and purchase intention? So now I'm testing the moderation of PQ. So now I'll run line number 137. Yes. Okay. I'll select this and run it. By the way, it is showing me could not find constructs. Why? Because I have just opened the R Studio. First, I need to uh, bring the seminar command. I have to load the seminar command. Yes. Now all of you just pay attention. So now again, let me run line number 137. Now see it is reading it because earlier seminar package was not loaded. Now again for 5 steps, specify the model, specify the measurement model, specify the structural model. So here you can see structural model. I have created an interaction term SIC into PQ. So line number 145. Yes. Okay. And let's plot the model. So when you plot the model, you get this graph. So this is the statistical model. It means we are testing the interaction of SIC and PQ on PI. So if this interaction term SIC into PQ, if this is significant, we say yes, in the presence of perceived quality, the relationship of SI and PI gets moderated. Yes. So if this interaction term becomes significant, then only we can comment that there is a moderation or there is an interaction effect. Otherwise, there is no moderation. Now let's estimate the model. These are all standard steps and it's very mechanical. All 222 observations are valid. So let's summarize the model. Okay. And let's see the summary statistics. So now here you can see, but SIC, PEC, this is the beta. This is the beta and rest R square, all those things. This is R square and this is adjusted R square. This is the effect of SIC on PI. This is the beta. The effect of SIC on PI is 0.153. The effect of PQ on PI is 0.549. And lastly, the effect of the combined effect of SIC and PQ is 0.208. But now we have not, we don't know the beta, we don't know the confidence interval p value or t value, but beta is there before us, and you can see that all the reliability indicators are decent. You should skip the reliability and convergent validity indicators for the interaction term. Yes, you should not talk about alpha, composite reliability, AVE, or Dijkstra-Hensler row reliability for the interaction term. That you should skip because you can't estimate the reliable convergent validity and discriminant validity for the interaction term. Okay, so now let's bootstrap the model. So I'll simply select line number 167 to line number 170 and simply run it. So the model is getting bootstrapped. So here you can see this red blip. So we have to wait till this blip is on. Okay. Now, lastly, let's run line number 172. Okay. And if I simply just copy this and simply run it. So now here you can see, let me put this down. Here you can see, here you have the bootstrap structural paths. That is the direct path. So direct path, SIC, PI, this is significant. See the bootstrap confidence interval. There is no zero, there is no negative sign. And PQPI, again, this is significant. See the T-stats also, it is supporting it. And the interaction term, SIC into PQ, again, see the T-stats and again, see the confidence interval. So now I can say that PQ moderates the relationship of SIC and PI. SIC and PI. So there is a moderation. We can say that there is a moderation. Now, today we'll focus on model comparison, my friends. Today we'll focus on model comparison. Now, before we go on model comparison, let's read what is written about model comparison and how model comparison has to be done. Now, these are some advanced modeling issues that we need to take care of. So here in that seminar book, we have this evaluation of the structural model. And here we talk about 6.5, page number 121. We talk about model comparison. So model comparison. So now let's focus on this. So once you tested the mediation, moderation, or predictive validity of the model, and let's say if your goal is to test model comparison, then you should go for it. Now, normally when you have a single model, let's say you have a single model and you're writing a paper around a single model, then the question of model comparison will not arrive. But if you want to see that that which model fits the data better. Which model fits the data better. Let's say you have conceptualized a mediation model, and now you are you also want to check whether uh, uh, a particular construct is more supporting mediation or moderation. Then in that case, you should check this competing models. Otherwise, if you have conceptualized a mediation model and moderation model, and you are writing paper around a single model, then you need not go for model comparison. Now, normally people who are in computer science or people who are in, let's say, stats, so they do this model comparison and they try to say that this model is better than the previous model. So, if you want to understand the relative likelihood or the relative betterness of one model than the other, then you should go for model comparison. Now, most of the papers that we write, we normally don't talk about model comparison. So, this step normally we stop up to assessing the predictive validity of the model, and we don't talk about model comparison. But let's say if you want to understand model comparison and you want to estimate that which particular model explains your data well, then in that case we should go for model comparison. So here it is said in a final optional step. Again, it is an optional step, it's not mandatory. So all your analysis should stop if you are testing only one model till assessing the predictive validity of the model, that is PLSpredict. So PLSpredict will be the last step for you. So now this is an optional step. Researchers may be interested in conducting model comparisons. So models are compared across different model configurations resulting from different theories or research contexts and are evaluated for predictive power. So whenever we are evaluating a model, we are talking about that which model has a better predictive power. Using the existing data, which model has a better predictive power. So that model which has a better predictive power, that will be selected as the preferred model. Now here, if you focus on this, so again, Sharma et al., you should read their paper, and this paper is cited in this particular book. So recently compared the efficacy of various metrics for model comparison task and found that Schwartz, Bayesian information criteria, and GVK and Mace's criteria achieve a sound trade-off between model fit and predictive power in the estimation of PLSpath models. So there is one paper by Sharma et al., and they support that in 1978, Schwartz, they talked about Bayesian information criteria and GVK and Mace criteria. So these two criteria should be used in order to understand that which model fits your data well and which model has a better predictive power. Okay, so these model selection criteria facilitates the comparison of models in terms of model fit and predictive power. So this again, let me write it. So we'll focus on BIC, and second we'll focus on GN. But later on the author says no, simply focus on BIC. BIC is the far better matrix. Okay, so now here you see in applying these metrics, researchers should estimate each model separately and select the model that minimizes the value in GIC or GM for a certain target construct. So if your BIC value is lesser, let's say there are two models. So one model has one BIC and the second model has another BIC. So a model which shows you lesser BIC, that model we are going to support it, and that model we are going to take forward. Yes, okay. So again, then there's so many things they're talking about. Then they're talking about this cross-validated predictive ability test, CVPAT. Yes, again, it is given by this particular author. You should read his paper, Lingard 2021. So by the way, CVPAT, it is not there in seminar, but it is there in CSEM. So today we'll also explore CSEM package. By the way, today's day will be very hectic because after model comparison, we'll see multi-group analysis. And after multi-group analysis, we are definitely going to see complex models, and then we'll estimate the complex model using CSEM, a new package, which is very capable and more robust than all the other packages known in PLSSEM. Okay, so now here you focus on this. Here you see, whenever you evaluate a structural model, so here the authors have given the rules of thumb for the structural model assessment. So first you should focus on collinearity. Whenever you are testing a model, see the collinearity. Your VI values preferably should be lesser than 5 and more better if it is lesser than 3. Then check the significance and relevance of path coefficient. You should check the path coefficients. Then check the R square value. So there are three R square values, 0 0.5, 0 0.75, 0.5, and 0.25. So which one is better, you accordingly decide. Then you should go for PLSpredict and focus on the indicators of the endogenous construct. The main construct that is there, focus on the indicators. And if your PLS out of sample RMSE errors are lower than the LM out of sample model, then you should say that your model has a predictive power, high, low, or medium, whatever it may be. And lastly, the model comparison. So model comparison comes after PLSpredict and only when you have competing models. If there are no competing models, all your analysis will stop up to PLSpredict. Now let's focus on this. Select the model that minimizes the value in BIC or GM compared to other models in the set. So we'll take models which have lower BIC. And again, you can also compute Akaike weights for additional evidence for models' relative likelihood. So apart from BIC, you can also compute Akaike weights. So we'll see this. We'll see this. So now, friends, now this syntax is there for you. You can practice along with me, and let me clean the screen. Okay. So now I'm going for model comparison. So from line number 178 to let's say yes, line number 178. So we have estimated this moderation model. Now we want to go for model comparison. So just a second. Where is that? No, just a second. So here we took the just a second. Where is that? Which type the model? I think I didn't go for this. Just a second. That mediation model I didn't create or what? Okay. Friends. Okay. So yesterday, focus on this line number 135. So yesterday we checked moderation for what? We checked moderation for PL. We check moderation for, sorry, this is moderation for PQ, sorry. This is moderation for PQ. This is, okay. Where is that? We checked the moderation yesterday, no? Just a second, let me check. I think that part is skipping because we will compare one moderation model with the another moderation model and we'll compare their BIC. Okay. So give me some time to bootstrap the model. This is assessing indirect effects. Model's predictive validity. This is the moderation. Okay. So here we have summarized the model, bootstrap and model comparison. Okay. So now here we are going for model comparison. So we estimated the moderation model. Conceptualizing PQ moderates the relationship of SIC and PI. Now, what I am doing, this is the model that we tested yesterday. If you focus on line number 182, it was stopped. So I've rewritten the syntax in the morning. So this syntax is there with you. So now let's do one thing. So all of you just pay attention. To simplify matters, I think a couple of you didn't attend the previous session. So all of you just pay attention, friends. So I have two models. So one is SIC, the relationship of SIC and PI. And here I am taking PQ, that is pursued quality, and I am calling this as model 1. And my next model is again SIC. SIC has an impact on, let's say, PI. And now here I am taking pursued likeness. So this is my model 2. You can have any number of models. You can make comparison. Now I want to know that out of these two models, model 1 and model 2, which is a better model? Which model has a better predictive power? So I want to check the predictive power of both the models. The predictive power of both the models. Yes. And what criteria I'm going to see? I'm going to see BIC. That is Bayesian information criteria. Yes. The model which gives you lower BIC, the model, let's say this model will give you 1 BIC. Model 1 will give you 1 BIC. Yes. And model 2 will give you another BIC. So I'll compare both the BIC, and wherever the BIC is less, that will be a better model. Okay. So now come to the R syntax. So here we have gone for model comparison. So again, I'm running line number 182. Yes. Now I'm conceptualizing PL as the moderator. Very simple. Don't get confused. If you have doubt, unmute yourself and ask. Then let's specify the model. This we did yesterday. Okay. Then let's create the structural plot. Now here you can see things have changed. Now PL is the independent variable. And now we are checking the interaction of SIC and PL. So let's do one thing. Select this. All observations are valid. Select this, and let's bootstrap the model. Let's bootstrap the model. Okay. So the model is getting bootstrapped. Okay. And just a second. Okay. Now summarize the bootstrap results and simply use this. Now friends focus. Now friends focus. Now when I took PL as the moderator, so SIC and PI relation is insignificant. PL and PI, pursued liking, will lead to purchase intention. This is significant, but the interaction term is not significant. Now you will go and say, okay, the first model is better because I'm getting all the significant results. Yes, no. Simply by looking at path estimates, simply by looking at the path estimates of direct and indirect effect, you can't conclude that which model is better model. Okay. So now you know that I have two models. I have two models. Now focus on line number 22. Now I'll go for model comparison using BIC criterion. So first model is that SIC, PQ, and PQ is the moderation, and second model is SIC, PL, and the interaction term of PL. So I have two model. So now if you focus, uh, when you bootstrap, see when you bootstrap, when you summarize the bootstrap result, no, let's say if I simply run this, so I'll get this, no. So press upper arrow key and simply put dollar. Okay, I think dollar will not suffice. No, this will not suffice. Can you see this command line number 227? This is summary infer model estimate 2. Okay, so summary infer this. So that summarized model, if you take this, so let me run this. Press upper arrow key and put dollar. The moment you put dollar and press the upper arrow key, this is IT criterion. Yes. So this summarized result you should choose. This summarized line number 208. So when you run this, you get this. See, you are getting this AIC and BIC information, Akaishe information criteria, and Bayesian information criteria. So this is your BIC. So this is your BIC for which model? This is your BIC for which model? For PL model, where PL is the moderator. Yes, and I've called it as, I've named it as 2. Yes, okay. And now just focus here. So now what I'm doing, let me run this line number 227. If I run this, I'm getting AIC, BIC both, but I'm not interested in AIC. So here in line number 28, I'm instructing the RStudio, give me only BIC of the dependent variable. That is purchase intention. So I'm running line number 228. So when I run line number 228, I'm getting Bayesian information criteria for model where PL is the moderator. So this is the Bayesian information criteria. Okay. Now similarly, uh, now I can estimate the Bayesian information criteria for model 1. Yes. I can estimate the Abhishek, mute yourself. Abhishek, just mute yourself. Abhishek, mute yourself. Okay. So now, so these are some steps that I've written. So I'm saying assign the model name to the modcom vector. So I've created a vector name modcom. So I'm running this and it says object modcom not found, but I have to run this first. Now friends, pay attention. So this summary infer mode estimate IT criteria, this will be for uh, model 1 where PQ is the moderator, and this will give me BIC for model 2. So now what I'm doing, I'm combining both the BIC and PI that I require for both the models and creating a vector called modcom. So I'm creating a vector and just storing all this value. So this is this value, this line number 2 to 228. It is for second model, and similarly, this one is for model 1. You can see this estimate 1. So I've simply changed the 1 and 2. So if I run line number 231, yes, yes, okay, it is giving me yes. And now you can simply name it. Just combine and name this. So again, even if you skip this step, it will be fine. You do not run it and simply say modcom. Okay. Now, friends, interpret. Your model 1 is this, where PQ is the moderator. Your model 2 is where PL is the moderator. Now tell me which one is better. Which one is better? That model will be better model where BIC is less. Now this is the BIC of model 1 and this is the BIC of model 2. Which model is better? Tell me. Come on. Which one is lower? Hello? Hello? Bouncer? Bouncer?
Model 1, sir.
See, okay. So Hemant says model 1 is better because it has lower BIC. What about others? What about others? Hemant would go with model 1. He will choose model 1 because it is explaining better. What about others? Hello, what about others? No answer? Now, friends, pay attention. Whenever there is a minus sign, higher one is always the lower. Hemant, first of all, let us appreciate Hemant that he had the courage to speak. But see, 10 is always better than 1. But if the sign changes, 10 will be smaller than 1. So if you compare both the models, BIC is less here in model 2. So I will go with model 2 because this is giving me lower BIC. So model 2 is better, Hemant, because you have to choose that model where BIC is less. So BIC is less for model 2. Now remember, minus 183 is lesser than minus 102. Just remember this. So model 2 is better. Model 2 is better. Okay. Now again, see, I am not saying this. This is what Sharma et al. They are telling it. Can you see this? All of you just pay attention. Sharma et al. Yeah, Bayesian information criteria and GVK may say this is not required. So again, they are saying where BIC is less, So that model is far better. Can you see? When comparing different models, researchers should select the one that minimizes the BIC value for a certain target constructs. So let me select this. So this line says that whenever you are comparing a model, you should select that model which has low BIC. So when now my low BIC is in model 2. So model 2, where PL was the moderator, is relatively better model, even though they are not significant. Even though they are not significant, that model is a better model. Okay, this is what the authors are telling. Just a second, somebody, my baby has just focus. Okay. Okay. Yes. Okay. So now friends, don't get confused. I'm sure because the syntax is very confusing. The syntax is given here. I'll show you. In fact, even I have borrowed the syntax from this particular book. Okay. Don't get frightened by looking at a technical syntax. So let me scroll down. See here the syntax is given. Focus. Just a second. I have to scroll down. See, the entire syntax is borrowed from here. Okay. The syntax is given. Don't worry yourself. You simply need to borrow the syntax and put it in your script file and just run it and just check which model is giving you lower BIC. Yes, and lower BIC is given by model 2. And now later they are also checking the calculate the model. Here you see calculate the model BIC Akaishe weights. You can also calculate the Akaishe weights. So again, this is the syntax. So now I can calculate the Akaishe weights. So simply if I run line number this, so now I'm getting Akaishe weights. So BIC should be lower and Akaishe should be greater. So again, these are very small amount. So again, this says that this model is far better because any number, see 1 raised to power 10 plus 0, this value will only be 1, but this value will be very less. You can check in the computer. So here BIC is less and here Akaishe is more. So all indicators are telling me that model 2, where pursued likeness is there, that model is a better model. Okay. You simply can't judge a model simply by looking at the beta estimates, or if all the coefficients are significant, you can't say that model is better. So perceived likeness, it means what? Now let's interpret. self-influencer connect, whether you are able to connect yourself with some of the other influencer or not. Or let's say you are connecting yourself with some influencer, and if you like that particular influencer, so that purchase intention is going to be high, even if you don't like the product. Even if you see, by the way, when you test the real data, close the door. Close the door. When you test the real data, my friends, so there that pursued quality means uh, influencer connect is there, pursued quality should be there. Then only people are going to develop purchase intention. But no, but when you are testing the model, it says that if you like your influencer and if you are able to connect yourself with the influencer, then in that case you are going to develop purchase intention. Means uh, influencer connect, if it is supported by pursued liking, then the purchase intention will be high. So model 2, where PL is the moderator, that sounds a better model according to BIC and Akashi weight criteria. This is what it is telling. So this is what model comparison is. Now we'll also see model comparison using CVPAT. Now you should go for CVPAT. You should always go for CVPAT. So CVPAT is not available in seminar. That is there in CSEM package. So we'll definitely see CSEM package and we'll see that which model is a better model. Okay. Now friends, yesterday we didn't cover one important topic. Yes. Okay. So all of you just pay attention. All of you just pay attention. So now, yes. So all of you just pay attention. Let's talk about moderator per se. So moderators. Now, please remember, moderators are of two kinds. Yes, moderators are of two kinds. One is your continuous moderator. One is your continuous moderator. And second is your categorical moderator. Categorical moderator. Now, when I say your moderator is continuous, friends, when I say your moderator is continuous, it means your moderator is a construct that is measured using multi-items. Measured using multi-items. Now, in the SIC PI purchase model, pursued quality and pursued likeness. Yes, they both were measured on Likert scale. Yes. So when a moderator is measured on Likert scale, or if your moderator is a continuous moderator, then we definitely check the interaction of that. But let's say if your moderator is categorical. When I say categorical, it means let's say gender. Now, how do you measure gender? Gender, either a person will be male, female, or others. Now, in most of the case, you never find others. Gender will only take two points, male or female. Gender will be binary. Yes. Or let's say you ask somebody's age, not in completed years, but let's say you give slab. Let's say 18 to 25, 25 to 40, 40 to 55, and 55 to 65. So again, age can also be measured as a metric variable, continuous variable, or a non-continuous variable. So when you measure a particular variable as a categorical, let's say you are asking somebody's designation. Now designation, it can be trainee, junior, or senior. Or let's say you are asking somebody's educational qualification. So either he could be a bachelor's or he could be a master's. Yes. Okay. So when your moderator is categorical, yes, please remember, here we perform MGA, or that is multi-group analysis. Multi-group analysis. Now, in short, it is known as, the acronym is MGA. So moderators are of two kind. One, when the moderator is construct. When the moderator is construct, it is very simple. Create the interaction term with the independent variable and check the effect of the interaction term on the dependent variable. If it is significant, we'll say it is moderator. If it is not significant, we say the moderator has no effect on the relationship between the independent variable and the dependent variable. But if your moderator happens to be a categorical case, case means, now let's say, all of you just pay attention. Let's say you are checking this particular model. Okay. So SIC has an effect on, let's say, purchase intention, and perceived quality is going to moderate this particular relationship. Now see, when to go for MGA? Again, it is the researcher's objective. See, what you feel that, see, you have collected data from, let's say, 500 people, and you run a model and you test it, and you say, okay, paths are significant. Now, if you do multi-group analysis, let's say if you bifurcate the data, into male and female, now you will find that for male, this model PQ is significant. Now you can have a very interesting finding. For male, it can so happen that the moderator is significant. And you will find that for female participants, this moderator is insignificant. Now, if you take all your data and you comment on the overall model, don't you think you are presenting a picture which is very, very erroneous? Now, somebody would say, okay, your data has male and female, and male and female, they behave very separately. Okay, they have a very different set of behavior. Yes. So go and check the multi-group analysis where your model result, is it same for male and female, or are there any divergence, or is it difference? So normally when you present your model results, you say that everybody is same and the model behaves this way. But if you do multi-group analysis, you'll get to know the difference in the path estimates. What is significant for one group may not be significant for the other group. Yes, and vice versa. So it is always advisable to go for multi-group analysis. Now, to give you more clarity, my friends, let me do one thing. Let me show you one paper. So this paper will give you a more clarity. Just a second. So there is one paper, yes, new research, and research paper 2. Now, again, this abusive, uh, see this abusive supervision and coping strategies among Indian professionals. It's an IMB review paper. Yes, B category paper. And here, if you see, this is a model. Somebody has tested this model. So if you focus on this model, there are how many mediators? There are 5 mediators. Abusive supervision is independent variable. Burnout is dependent. And between these two, there are five individual mediators. It's not a case of a serial mediation, my friends. So somebody is testing 5 mediation in the relationship of abusive supervision and burnout. It's not a case of a sequential mediation or serial mediation, because mediators are not connected. Somebody has gone ahead and checked these 5 mediators. Yes, and they have controlled for age, gender, and experience. You see how control variables are controlled for, and see how they are put into the model. Now here the authors went ahead and tested, and later on, and they say, yeah, okay, this is the result. They say, okay, some things are supported and some things are not supported. Now, when you present this table 3, or standardized direct and indirect effect, you assume that all the units of the population are homogeneous, but actually it is not. So when you present a consolidated result for all your sample, you are under this assumption that everybody is same, and everybody is going to behave the same way. By the way, hypothesis is actually you're testing the behavior of general people, majority of the people. Now somebody might question this. So what these people did, they went ahead and performed MGA, that is multi-group analysis, and see what are they telling. So now this is multi-group analysis for group 1 and multi-group analysis for group 2. And see, this is the beta estimate here, and this is the beta estimate here. Now this is the beta estimate for this particular relationship, 0.180, and this is the beta estimate point 0.358. Now you want to know whether this beta estimate and this beta estimate, are there any significant difference. So use significant differences assessed using p-value. By the way, this multi-group analysis is nothing but a special case of independent sample t-test. Multi-group analysis is nothing but a special case of independent sample t-test. So when you say, okay, the beta estimates for 2 groups are different, but are they significant different? Now here, if you see p-value, if you focus on the p-value, none of the p-values are lesser than 0.05. it means there is no significant difference. Everybody is behaving the same way. Yes. So even if the authors have gone ahead and presented a result saying that, okay, there is no significant difference among the groups that is there in our data, but they have checked only for one particular variable. Now you can check for designation, you can check for a different age group, you can check for, let's say, designation, you can check for many. But if you go on checking for multiple things, there is bound to be lot of divergence. So take one variable based on literature review, where you find that yes, previous literatures are talking about that this is the one variable which is going to have different impact for different set of people. So if I can identify one variable based on literature review, you can consider that variable as a categorical variable and check for MGA, that is multi-group analysis, and see whether differences exist between the group or not. So this is how people go and report it. So again, if I take you, moderators are of two kind. One is your continuous moderator and second is your categorical moderator. So if your moderator is categorical, yes, then you should go for MGA, that is multi-group analysis. Now, if you focus here, so yesterday I could not show you MGA. Now, I will test MGA for which particular model, where PQ is the moderator. Remember, this when you see this estimate 2, this is PL is the moderator. Whenever you see here, so this is for PL as the moderator, and wherever you see number one, this is your PQ as the moderator. So simply I will run line number 245. I'll keep my cursor here. Let me slightly enlarge this and see. I'll run my cursor here. So it is telling me object influencer group not found. Can anybody tell me why it is not found? Because I have not attached the influencer data. So this is the influencer data I have not attached. Yes. By the way, if you can see, press the upper arrow key and remove the attach and say ls. Now this is an influencer group, which is a column. Influencer group is a column in the influencer data. So it was not attached, and that's why it was showing me error. So I attach the influencer data. Okay. Now I can run it. I can simply run it. So line number 245, see the syntax. See the syntax. By the way, my friends, this estimate PLS MGA is a function which is there in the seminar package. Okay. So what I will do, I will simply run line number 245. Yes. And see, it is now normally it does bootstrap. So it will take some time because it's a very complex process. So it will take some time. It takes some time. Okay. And it is, so see, now it is bifurcated. All 122 observations are valid. Means when I say group, there are two groups. So 0 is 122 and 100 is, sorry, 0 is 122 and 1 is 100 observations. So it divided. So when you do multi-group analysis, let's say female are 122, male are 100. So it will divide the two file. So here you can see two numbers, all 122 observations are valid, all 100 observations are valid. Means it has divided the file. Now it will run separately. It will separately run the model for two groups. That is for 122 group and 100 group. Hope everybody is understanding. And now simply select this and simply run it. Now here you see PLS MGA results. PLS MGA results. So SIC to PI. This is the beta estimate for group 1. This is the beta estimate for group 2. There is no significant difference. There is no p-value is greater than 0.5. It means there is no significant difference. By the way, all the term you see, p-value is greater than 0.5. It means there is no significant difference between the groups. So the overall result that you found for 222 observation is slightly valid, is valid. So multi-group analysis. Multi-group analysis is a special case of a moderator. Just bear this in mind. So just in next, I think it's almost now 6 o'clock, 7 o'clock. So in just 50-minute session, we learn two important things. One is your model comparison, and second is your multi-group analysis, which is a special case of a moderator. Okay. Now let's proceed. Okay. So see, any discussion on PLS SEM will be incomplete if we don't take higher order models. Okay. So now, see, I have given you two. See again. By the way, I am not yet completed with model comparison because I have not shown you CVPAT. I have not shown you CVPAT. CVPAT is even robust. Okay. BIC, uh, Akaisha and BIC and all. It's okay, fine. Now there is one function called CVPAT, cross-validated predictive ability test. Yes, and this function it is there only in CSEM package. By the way, CSEM package is more advanced than any other package which is there for PLSSEM. CSEM package is more advanced. It can handle every kind of. By the way, PLSSEM is just one algorithm. Please, PLS partial least square is just one algorithm. There is consistent PLS. There is ordered PLS. I'll show you simply. Simply show you question mark. CSEM is so robust, it can handle any kind of PLSSEM. If I can simply zoom this, here it says CSEM, a package for composite-based structure equation modeling. So when I say composite-based structure equation modeling, this is nothing but your PLSSEM. So here you can see PLS is a family, and smart PLS only takes care of normal PLS and consistent PLS. So here you can see this is PLS is one algorithm, and there are derivatives of PLS like PLS consistent, ordered PLS, robust PLS. See, there was a controversy. People started criticizing PLS SEM, the way it estimates the latent construct. Then there are a lot many authors who came out and refined this PLS SEM by coming out with new algorithms. So there is PLS consistent, there is ordered PLS, there is robust PLS. There's so many things it can perform. CSEM. So CSEM package is mother of all package, I can say, if PLS SEM analysis has to be performed. Okay. Now, if you want to see the syntax of PLS, all of you just pay attention. See what I'll do. Let me minimize this and let me type one word here, question mark, Vignet, and in bracket I will write CSEM. Okay, and press enter. Now see what happened here. So, so this is giving me a Vignet. Again, it is not okay. So let me do one thing. Let me take you to CRAN. Simply type CSEM package. This is my Google, by the way. I use Microsoft Binge. So CSEM package in R. So simply press, it will take you to CRAN. By the way, can you say this? This is all capital, leave it. Now, by the way, Binge has Chat GPT inbuilt into it. Okay, so leave this and focus on this. CRAN package CSEM. Just press on it. And here you can see within it should be there. Okay. You can see the syntax. See Vignets. See the notation. See, you get everything. Let me go back. And then terminology. See, all the syntax and all you'll get, all the syntax. Yes. And then using assess. See, they have given how to assess models and all so many things. Yes. Okay. So many things they have given. Okay. And then CSEM basic. Basic means, see, you'll find all the syntax and command when you go to Vignets. There are only 4 commands. See how to write a structural model. See, all of you just pay attention. See, the syntax for R in CSEM package is different. So first, you will specify the model. First, you have to specify the structural model. When I say structural model, it is the relationship between the constructs. And after that, you have to define your measurement model. Means how are you measuring a particular construct? I think Kiran did ask on the WhatsApp group that how you define or how you measure a construct. See, so you left hand side, you write the name of the constructs equal to tilde, and then you provide the Excel column. Let's say OCB1, OCB2, OCB3 this way. So similarly, this is the syntax. This is the syntax. So now what I'll do is that all of you just pay attention. Now what I'll do, I've given you one data set. Yes, I've given you one data set. So let me quickly show you that particular data set. What is that data set all about? So all of you just pay attention. So this is my PhD data. So I've collected over a span of 6 months from healthcare professionals who are associated with pharmacovigilance firms. Yes. So this is gender, age, education, experience, office location. Where are the office located? And this is the designation. And this PA1, P2, it measures quantitative performance. And this, forget about PA3, because in the original file, this is not there. This is OCB. Yes, this is one construct. Then this is another construct, OCO, organization identification. Then this is LMX, LMX1 to LMX7. Yes. So these are all constructs. Then this is PC2. So these are constructs. Yes. And this file has been shared with you. Okay. So now what I'll do, let me check, is this file here, D data? D data is not here. So just a second, just a second. It is here. I'll take it from here. So this D data I'll simply copy from separate file. I've shared with this, by the way. I'll simply put it here. Control V. Okay. Now, friends, all of you just pay attention. Now let me take you to a Microsoft whiteboard. All of you pay attention. All of you just pay attention. Hope my screen is visible to you. Hemant, Felix ji,
Yes,
Abhishek
sir.
Yes,
ji,
sir. Visible, sir.
yes, Kiran and I think my friend from Kolhapur, Gandhali. Gandhali is there, by the way, today. Okay, Gandhali maybe not there. She is not there. And what about Sonam is there today? Sonam, are you there? I think many people have skipped today.
No, sir, she
Okay.
is.
Sonam is there. Okay, okay. Now, friends, all of you just pay attention. All of you just pay attention. Okay. See, now I'm testing a very complex model. All of you just pay attention. Yes. But by the way, let me show you model comparison in. So which is this model? Yeah, I've taken a simple model. If you focus on the R Studio, here I've taken a very simple model. Okay. I've got the syntax. All of you. See, friends, what I'm saying that just a second. Suddenly something happens to my this black pen that I'm not able to see the dots. Okay. Just a second. Give me some time. Mhm. I'm not able to see the dot or okay. I have to select this. Okay. All of you just pay attention. Just pay attention. Huh? See, I'm testing a model. Yes. So LMX. Now this is an OB example. So far we were discussing the marketing example. Now we are taking a OB example. So LMX. What does LMX stands for? Leader member exchange. Means how good you are with your leader, or how is the relationship quality that you have with your leader. I'll tell you one interesting fact. I have almost 15 plus years of experience in academics, but I was never in the good books of leader. So, and leader was not in my good books. So we always were sworn enemies to a certain extent, huh? Not sworn, to a certain extent. So, so see, the relationship quality at the workplace will decide lot of outcomes. Now, similarly, if you are working under your guide, so you should have good quality relationship with your guide. Otherwise, guide will make your life hell. Fortunately, I had a very considerate guide when I was doing a PhD from Pondicherry University, Dr. Riyasuddin, I take his name, a very humble and down to earth person. So 5 years I was under him. He never created any problem to me, never. And he was such a down to earth, always facilitating, always helping. And he made my journey so nicely in Pondicherry that in the month of November 2023, I was awarded my PhD degree. So it made my life very easy. At the same time, he kept me on my toes, and he never allowed me to take shortcuts, or he always focused on rigor. That's why I was able to do a quality PhD and become a resource person also in later on. So let's say LMX. What is the relationship quality that you have with your leader? So if you are good in the books of your leader, you will identify yourself with the organization. OI is organizational identification. Now, when I say organizational identification, it means, do you identify yourself with the place of your work? See, we all identify ourselves with a family. If something happens to our family members, it is we who feel the pain. But let's say if something happens to your organization, do you feel the pain? So that is measured by organizational identification. Yes. Okay. By the way, there is one strong antecedent of organizational identification. It is the managerial policies and practices. So if your organization has good managerial policy and practices, definitely you will identify with the organization. But if you find that if your leader is troubling and management has not created good policies, you find it difficult to take casual leave and all, then in that case you don't identify with the organization. So there are antecedents to organizational identification. And by the way, if you identify yourself with the organization, you will engage in, let's say, organizational citizenship behavior. Now, what is OCB? OCB is going beyond your job performance, or let's say going beyond your job description, not performance. It is going beyond your job description. When I say going beyond your job description, it means you are doing those things for the organization which is not part of your job description. Let's say if somebody criticizes your organization, you'll say, no, please don't criticize my organization. It is my bread and butter. Say you recommend the products of your organization to others. Now honestly tell me, if you're working in some organization, would you recommend your organization to your friends and relatives? So if you recommend the services of your organization or the product of your organization to your friends and relatives, it means you are engaging in citizenship behavior. So citizenship behavior is measured using 8 items, which is there in the Excel sheet. So let's say, so there is one direct path from LMX to OCB, and then there is an indirect path from LMX to OI and from OI to OCB. So now this is a case of a simple mediation. This is the case of a simple mediation. This is the case of a simple mediation. When there is only one mediation in the model, it is a case of a simple mediation. So now see, I'm going to teach you CVPAT, that is cross-validated predictive ability test. Again, this is used for model comparison. Yes, this is used for model comparison. So now in the R syntax that I've given you, I have taken two models. So this is my model one. This is my model one. And now I've also given the syntax for model two. Now in model two, what I'm testing, I am testing the impact of LMX on OCB. And now I'm conceptualizing OI as the moderator. So I've taken two model. So this one is the mediation model and this one is the moderation model. So now I have written the syntax. So this file has been shared with you. You can go to the vignettes. See, first of all, you can't manipulate the syntax. You can change the construct name, but if it says that tilde is required, means tilde is required. If it says equal to or tilde is required, it's required. Now all of you just pay attention. Let me slightly or let install the package. This is the command, but already it is installed in my machine. So I will simply run line number 8. I am running line number 8. All of you just pay attention. Okay. Now pay attention. Now this is the syntax. Now this is a vector, by the way. You can write anything, model, and you need to start this way, double inverted comma. And first write the structural model. What is the structural model? So structural model is first arrow. Now this is a mediation model, my friends. So one arrow goes from LMX to OI. So here left hand side will be dependent variable. Please note this. Here things are very different. See, every package will have a different way of writing your measurement model and structural model. So when you are using CSEM, to the left side you will write the dependent variable, and to the right side you will write the independent variable. You remember how you calculated regression? LM, MPG depends upon horsepower. Yes. So the syntax is like writing a regression equation. Just remember this command. Tilde means depends upon. So organizational identification depends upon LMX, and OCB depends upon LMX and OI. Yes, LMX and OI. See, this is how you need to write. And then give the measurements. So LMX is measured from 2, 3, 4, 5, 6, 7. By the way, LMX, you can see one missing. LMX one missing. You know why it is missing? Let me write it because actually its loading was less, so I removed it. But let me write it. So LMX is measured using 7 items. Okay. Then OI is measured using how many items? 5 items. And OCB is measured using 8 items. So yes, Kiran, raise your hand. Yeah, Kiran, go ahead. Yes.
Sir, this is the way we compute in R, or you have already computed in X data file.
No,
So
no, no.
basically,
No, actually, Kiran, I gave this example in some other class, but this is the way you need to compute it. Whatever you can see in the script file, Kiran, I have written on my own.
Okay.
So let me add it, OCB1 plus, but actually when I was testing it, so there were certain items which were having poor loading. So I removed them. Let's bring back. So OCB2 plus OCB3. Yes, okay. So first you need to define the structural model, then you need to give the measurement model and simply select this line number 10 to close the inverted comma and select here. Okay. Yes. Then estimate the model. Now estimate the model. See, the command is CSEM. This is the function and this is the vector or yes. Okay. So first you need to supply the data. The data is D data. By the way, have I imported the D data? No, I have not imported the D data. So simply import base desktop here, open. Where is D data? This is D data. Let me import it. Yes, import. See, D data is now in the machine. Okay. And now don't forget to attach it. Attach D data. So if you don't attach, you won't be able to use the column. Now, friends, all of you pay attention. See what I'm doing. I'm simply copying this CSEM V and putting a question mark. And see it is given. How should you write it? Everybody pay attention. So this whatever that you see within the bracket, it is given in the CSEM package. First, you need to provide the data, .d data. So D data. Then you need to specify the model. Then you need to decide that whether it is reflective or formative. So all my constructs are reflective. Then you need to decide the PLS path scheme. Then disattenuate equal to false. So if you don't do this, it will give you error. That's why I say CSEM is a very complicated package for first time. In my previous session, I conducted one session with Professor Vishal Gupta. Vishal Gupta, sir. There are 50 participants. And I used 3 packages, PLSPM, CSEM, and seminar. Last day, everybody was confused because I was jumbling from one package to another package and people were very confused. They gave a feedback that he was constantly running from one package to another package. And that's why they found it very difficult. So somebody wrote the comment. So this why, to simplify matters, I caught the tail of one package, seminar. And now we are at the fag end of the session that I'm touching this CSEM package. By the way, I'll tell you one nice example. I was teaching again some research scholars and faculty members in July 2021 in pandemic time. So it was an online workshop, and there was one participant from Odisha, and I was also stuck up using CSEM package. That CSEM package was creating a lot of problems. Then he worked on his own and he gave me this command: disattenuate equal to false. By the way, rest you can just copy it. So this he told me, sir, if you don't write this dot disattenuate equal to false, it will give you consistent PLS results. It will not give you PLS PM analysis. So such a micro level information he practiced after learning R from me, and then he later gave me. So which I used for my PhD thesis using disattenuate equal to false. So again, I'll tell you there are many commands which participants have later on connected with me and shared with me that, okay, sir, this is the command you can simplify the matters. So there are many participants and they're still connected virtually, WhatsApp and so many other mediums. And okay. So now estimate the model. First, here it is define the structural model, define the measurement model, and now estimate the model. So simply here also you can bootstrap. Here also you can bootstrap, or you can give 10,000 here. But I'm not going to give 10,000. I'm going to simply do it for 100. Otherwise, it will take a lot of time. By the way, this is very mechanical step. Only you need to practice. Only you need to practice. So simply run output. So now see, ये बहुत अच्छा देता है सीजन बैग एकदम. It's so fun, and you see everything will be tested. First, let's assess it. So when you'll get everything, even all the model fit indices in PLSSEM. As a seminar package will not give you model fit indices. HTMT2. See, there was Forner Lerker, HTMT, and then HTMT2. CSEM will give you HTMT2. CSAM will give you HTMT2. Yes, okay. So now here you see AV values, R square adjusted, Cronbach alpha. This is Jones-Cogro. This is composite reliability. Yeah? This is Cronbach alpha and this is composite reliability. And this is Dijkstra-Hansler rho. So you will get this value when you make this attenuate equal to true. So if you make this attenuate equal to true, no, you'll get this Dijkstra-Hansler rho. So Dijkstra-Hansler rho, it is there in consistent PLS, not in regular PLS. Huh? Just notice this. So again, I'm making this false. Otherwise, I'll forget. Now you see, there are so many other alternative ways of reliability. See, so many things it is throwing. Then this is all model fit indices, my friends. Now you should see SRMR, RMS theta, RMSCA, yes, goodness of fit. So many things it is throwing, my friends. So many things. And you see model selection criteria. There you remember model selection criteria in seminar. Here you see where is that BIC. Here you see BIC. BIC for the first dependent variable, which is mediator, and BIC for the final endogenous variable. Yes, okay. So you are getting the BIC. Yes, okay. And variance inflation factor, that is for checking the multipole linearity. You see Cohen's F square. Here you see HTMT. None of the values are greater than 0.5. Yes, and this is advanced HTMT, that is HTMT2 matrix. Now, earlier people were talking about HTMT matrix. Now they're talking about HTMT2 matrix. And then see Fornell-Lerker criteria. And then see this is the total effect and this is the indirect path. And see this indirect path. Indirect path means LMX, OI, OCB. And see this is the P value, this is the T stats, and this is significant. It means there is a mediation. It means there is a mediation. Now just infer the output. So when you infer the output, my goodness, you get so many things. So many things you get. Then predict the output. See, predict the output. Huh? Predict. See the predict. See that, yesterday we compared to RMSE, MEA. So you just see number of observation. This is your, by the way, this is a 99 sample that I've shared with you. Originally, I collected data from 310, but after cleaning the data, 268 sample was the size. So when you simply type predict output, no, you'll get the PLSpredict. Now, and here you see, you get Q square. My friends, here you are getting Q square. Please note, here you are getting Q square. Q square you are getting. So if Q square values are greater than 0, we say that model has a predictive power. This model has a predictive power if the Q square values are greater than 0. And here you can compare RMSE with the, yeah, okay. So this is, just a second, LM benchmark kaun sa hai isme? Estimator benchmark. Estimator benchmark is your LM. Estimator target. Okay, so you need to compare this with which one? With estimator benchmark. Benchmark, yes. You need to compare this with this. Yes, compare this value. Estimator target. This is PLSPM. Yes, estimator target. PLSPM. By the way, I'm not able to differentiate which is PLSPM and just a second. By the way, here you should use DA approach. DA approach. It's very complicated package, by the way, CSAM. See, if I go out to teach you CSAM package, it will take me even 4-5 days more. So, but I'm just giving you a brief as to how CSAM package functions. You did not type many commands, only it's very simple, my friends. Very simple. Just define the model, structural model, measurement model, estimate the model, and just 5 commands. Assess, infer, predict, summarize, and verify. In 5 steps, you get everything. That's the beauty of CSAM package. That's the beauty of CSAM package. Yes, okay. So now here you should, yes, Kiran, go ahead, yes.
Sir, but these 5 steps will vary with the kind of model that each one will have, right?
No, only, see, this step is fixed, Kiran. This line number 29 to 33 is fixed.
Okay.
Yes, only you need to change this one. Structural model and measurement model.
So, sir, if there is like another, like if I have in my model serial mediation or but in your model there is parallel mediation.
So there is serial mediation. So what I'll do? Okay, let me bring one more construct. Let me see. Just a second. So let me conceptualize a model. Okay, so let's say if I say just a second. If I say LMX leads to OI, leads to, let's say, OCB, and then it leads to performance. Yes. Even this can be done, Kiran. This can be done. See, by the way, Kiran, this higher order model, I've taken a very complex model, Kiran.
Okay.
In fact, this is a case of a sequential mediation. See how to write it. See, this is, by the way, the seminar package. But if I can go down, I have imputed using the same with the CSAM package. See, Kiran here, model 2. So see, again, what I've done, I've created a serial mediation for this. So only this will change, Kiran. Rest everything will be the same. From year to year, it will be the same. Only your structural model and measurement model will change, Kiran.
Okay.
Rest everything will be fine. Everything will remain the same. Yes, okay. Just go and explore CSAM package. It's awesome package. Awesome package.
Thank you, sir.
Okay. So you see PLSpredict, you are getting so fast, and you are getting Q-square predict. By the way, Q-square you didn't get in seminar package. CSAM will give you so many things. And CVPAT, it is there only in CVPAT is there only in CSAM package. So now predict, summarize the result. So when you summarize the result, you get confidence interval. See, so this is the direct path. So direct path, LMX to OI. You should read reverse, reverse. By the way, people who read and write Urdu, they write it reverse. No, Urdu is always written in a reverse style. They turn the book and write it. By the way, Urdu is a very fascinating language. Let me slightly different. Urdu is our Indian language. It is not connected to any religion or sect, but a lot of Muslims people speak. And Urdu is a very common language. I live in Ulhasnagar, and in Ulhasnagar, Sindhi is, if you write Sindhi, the script of Sindhi is Urdu. Sindhi is if you want to write Sindhi, the script is Urdu. Urdu is an Indian language. It has nothing to do with Pakistan or some Bangladesh or any other country. It is an Indian language. So why I'm saying Urdu? Because Urdu, all the textbooks you turn from reverse and you write Urdu from left to right. Normally when we write from right to left. No, Urdu people write from left to right. So any Urdu connoisseur, they will understand all those things. So now here you should interpret in a Urdu style. LMX has an effect on OI. Yes, this is the beta. This is the standard error. This is the T-stat. This is the p-value, and this is confidence interval. Remember, in seminar we never get this. We never got this p-value. In seminar package we never got the p-value. We only got T-stats and confidence interval. That's why I say seminar package is awesome. Sorry, CSAM package is awesome. CSAM package is very awesome, but very complicated also. Sometimes you'll not understand what is happening. So when I was working with CSAM, this one command dot disattenuate equal to false. Somebody from Orissa gave me the answer. Even I was teaching 3 packages at that time and I was confused in the workshop itself. Somebody recommended me, no sir, try this, you'll get a better result. Okay. So see, essentially, what is the idea? I want to teach you CVPAT. So now what we did, we ran a mediation model. Now we'll run a moderation model. By the way, see what are we doing? So this is our mediation model. Now we will run a moderation model. And we will check out of these 2 models, which one is better using CVPAT. So now I'm running a moderation model. Simply I'll run this. Just flow with the flow. Syntax are there with you, my friends. Please go and practice after the workshop gets over. There is nothing not to be understood. I know slightly we have to be faster because if I go on explaining the syntax for CSAM, things will be very, very complicated. Okay. So maybe maybe when I'm doing some future workshops on R, instead of taking seminar package, we can take CSAM package. But trust me, had I taken CSAM package at the outset, many of you would have been confused. So I always started something which is very popular. Seminar package is very, very popular. So I started with a popular package and then I'm shifting it to CSAM package. Don't worry. Calculations are very simple, not that deal. Vignettes, just check the vignettes. Okay. Then again, assess, infer, predict, summarize, verify. When you get verify, You get see all your results are so systematic. Okay. Then let's create the interaction term. Let's see, by the way, I'm running very fast because I want to teach you CVPAT. Yes. I'm not showing you all this interaction and all. Please bear with me because my intention is to teach you CVPAT. Object what not found. Please verify your model description. Just a second. Just a second. Okay, let me run this model. Okay, extract the constructs for create the interaction term. Sorry, I'm running this. You will not understand this what I'm doing it because the purpose is not to explain you CSM package. That this you can do in seminar package, interaction and all everything. Huh? Yes, let me run this. Yes. Assess, info, predict, verify. Okay. Now friends, just pay attention. Let me clean all this. So first, I have a mediation model. Second, I tested a moderated model. Now I want to compare which one is better. And if you want to check the moderation model, just check this summarize. Yes, and this the interaction of let's say OI on OCB or LMX on OI is not significant. It means here this if you interact LMX and OI, this is not having any impact on OCB. This is not having any impact on OCB. Yes, okay. So there is no moderation. You can just interpret. Now my intention is to teach you CVPAT. So I have two models. One is your mediation model and second is your moderation model. Now all of you just pay attention. There is simply one command. Test CVPAT. Test CVPAT. One command you can check model comparison. So first you need to provide the output of model 1. So where is the output of model 1? If you go here, see this is the term output. No, you should write here output or estimate the just write output and then next where is the output? This is output 4, this one. So just type output 4, press enter. What is it telling you? See, it's a very complicated process done very fast by CSM, my friends. Just pay attention. All of you just pay attention. See, this is cross-validated predictive ability test. This is used for model comparison, and this is more robust than BIC and all. Now, again, this is given by Lingard et al. 2020. You can read the paper. What is the null hypothesis? Null hypothesis will say both models perform equally. And if both models are doing well, they are same. There is no difference. When you say both models perform equally, it means there is no difference. No difference. Now see the test statistics. Your t value is less than 1.96. See, minus plus doesn't make any difference. When you interpret t value, minus plus doesn't make any difference. P value greater than 0.5, 0.05. So when p value is greater than 0.05, I fail to reject the null hypothesis. And what I conclude that both models are doing well. Means there is no much difference. There is no much difference. Whether you conceptualize LMX as mediator or moderator, it is not making any difference because I am not able to reject the null. I would have rejected this null hypothesis had my p value was less than 0.05. Yes, okay. So now CVPAT tells me that my both models are performing equally well. I can't say that one model is relatively superior and inferior. So you should run CVPAT. So CVPAT, it is there in CSM package. By the way, I didn't explain you the syntax of moderation and all those things. It's a very tedious process. Very tedious process. So I didn't explain you all these things. In seminar, you can handle very easily. Seminar, you can handle very easily. Okay. So any doubts, any queries, you can ask. Go ahead. Yes. Hello. No doubt, no query. Today, like everybody is silent. Okay, let me see.
Sir, actually, these results are more extensive as compared to seminar package. And it is not easy to comprehend from the results outcomes what we can see easily. But in seminar it is quite easy because we gave some instruction and the software itself has calculated and according to the need. But beyond to the need, the results are there. So in CSM it is quite complicated to comprehend.
But once you become seasoned, no, love sir, please use CSM. By the way, I'll tell you interesting thing. Yesterday, I think Sonam asked one question, whether sir can we use two packages and all. So I'm using
Even
two
this is my
packages.
question also, sir. So
Ah,
simultaneously we can use these two because what you told yesterday that in seminar you cannot find out the uh, q square or something, some values uh,
uh,
with RMSE and LMS. Okay, but here we can see two the values together. So can we use
yeah,
all the software
you
results
can
outcome?
compare. You can compare and you can write also. Nobody will reject your paper. See, by the way, I'm writing this paper and I'm testing this model. LMS leads to PsyCap, PsyCap leads to OI, and OI leads to performance, and I'm measuring performance in 2 dimension, in role and extra role. And here, if you focus this paper, everything I've written, I want to write the literature review and other introduction and all. This paper is pending since 5 months. I'm not able to write because I'm stuck up behind one paper facing continuous rejection. So here you see, can you see? Here I've said R and R Studio and OpenStreet's software were used to analyze the data collected in the study. Harman's single factor test, descriptive statistics, and correlation between the study variables were estimated using Psych package. The study used partial least square approach to structure equation modeling to account for robustness in terms of lab validity. PLS SEM was performed using a seminar package. So our choice of reliance on various, all those things I've written here. And here, if you focus on the analysis, I've used CSM package also. So this is reliability and convergent validity of the indicators. Yes, okay. Then here it is discriminant validity. Then this is bootstrap HTMT results of direct path. I think I've used only seminar here. There's no CSM package. There's no. Then here I've used structural model indices and all those things. Okay. So, but you can use in combinations and nothing wrong. And when I was writing the syntax, in fact, this syntax is for my paper itself. So if I can show you higher order constructs, sir, in the higher order construct, first I have estimated this model, complex higher model using seminar package, sir. Yes, using seminar package up till here. Then the same model, love, sir, I have tested using CSM package in very short command. But this writing these many commands, sir, it took me many days. Huh? It's not that simple that writing this command. Many places I was stuck up. But this command is ready. It is based on my research work.
So what we have to make some change according to the variables what we have, just as on the
Ah,
pasting these syntax, and we can find out the same results
ah,
according
ah.
to.
You can find it. You can find it. But to answer you, sir, seminar package is foolproof in itself. See, when PLSpredict you are using, no, Q square has no value. Q square has no value. So
Correct.
seminar package is very relevant, trendy, and it will help you to publish also. CSM is known for its complication, and CSM is very huge package, very huge. In fact, model robustness checks like there is Hosman test for endogeneity, then there is Ramses retest for checking nonlinearity effects. Everything is there. Even model robustness checks is there in CSM package. But model robustness checks is not there in CSM package. You have to do manually with other tests and so many other stuff. Okay. By the way, if I teach you endogeneity, the error in the independent variable uh, correlating with the error in the dependent variable, then the command runs over 2-3 pages. Endogeneity, just one checking endogeneity in your model. But CSM, but few button. But CSM, if you run it, it will not give you output. By the way, there is one book which which I have shared with you, written by Professor Hensler, and Hensler has contributed to the development of CSM package. So if I can take you to the reading material, not here, not this one, this one. So there is book, and this is the book I've shared with you, composite based structure equation modeling. Yes, and in this book, uh, Jog Hensler, he has used CSM package. But again, he has given very small, little information. Even he has not, in this book, he has not explored CSAM package in length. So see, CSAM package, here it stops till uh, giving the PLSpredict output and checking the CVPAT and all. But later part, checking the model robustness checks, CSAM package is capable of handling model robustness checks. But when I'm trying, it always gives me error. Maybe it doesn't understand the syntax and all. Maybe separately I have to sit and explore this package in detail. CSAM package, it's a very robust package. According to me, it's robust CSAM package. But this book has been shared with you. Just read it. And they talk about model fit indices also. See, seminar will not give you model fit indices because anyway, model fit indices is not a part of this PLSSEM. But still, if you read papers from IMB review, they talk about model fit indices. Yes, okay. And here, if you simply run this command, let's say SS, see, you get all the model fit indices. You see SRMR, they should be less than 0.06. You see this RMS theta. Again, it should be less than 0.80. Yes. And then people talk about these two people reported model fit indices. Then they talk about goodness of fit. It should be above 0.60. So people talk about when model fit indices in PLSSEM, people talk about GFI, people talk about RMS theta, people talk about SRMR. This you will not get in seminar package. Yes, okay. And there are so many things. If you want this advanced HTMT2 matrix. Yes, so there is HTMT matrix and there is advanced HTMT2 matrix. This you can get here. Okay, so very dynamic and very robust package. Very robust package. And see, model selection criteria, BIC, it's giving you. So take the BIC where it is lower. By the way, let's compare. See this model. Okay. Here also SS was there, no? SS. Let's see which model is better, mediation or moderation based on BIC information. So here BIC is 48 and here BIC is 54. So the mediation model is better. The mediation model is better if you focus on BIC because minus 54 is lesser than minus 48. Minus 54 is lesser than minus 48. So, oh, sorry, we have to see this also. Minus 61 and no, here actually there is only one dependent variable. Maybe you have to see only the BIC and select which one is lower. Okay. So very robust one. Very robust one. Okay. So friends, let us take a break. And it's almost 7. By the way, let me take some doubt. We'll take break after 10 minutes. Don't worry. Okay. Any other doubt you have? So we saw CVPAT. I think Sonam or somebody was asking, sir, show us CVPAT. So CVPAT is there in CSAM package. So we did focus on that. Okay. Any other doubt? Any other query?
Sir, model check comparing we go for when we have two moderators.
No. When we have two models. No. Not two moderators.
Okay. Two models we have got. Okay.
Two models. Let's say I'll show you this book, sir. So just a second. I'll show you this book. Just a second. Suddenly I'm not able to get that. Just a second. This seminar book is there, no? Seminar book. So here you focus structural model, sir. Model comparison. See here authors have. See, just a second. See, authors have 3 competing models. Loveji, can you see the screen?
Yes, sir.
So they have 3 competing models. So this is model 1. Yes. This is model 2, where there are paths coming from all the antecedents to the here. And this is model 3. Paths coming from SUSA and paths also going to SUSAL. So when you have 3 models, so now you want to see which model is better. So you will take model where BIC is lower. So here they have spoken about it. So there is 3 model, model 1, model 2, model 3. So minus 102 is smaller than minus 93 and minus 97. So we'll go with model 2. And if you take example of this BIC Akai weights, so model 1 is superior. See both BIC and Akai. Higher the Akai model, the better. Lower the BIC model, the better. So BIC and Akai both are favoring in support of model 1. Don't be in hesitation. Don't be in hesitation. Use Only seminar package. It's foolproof. It will suffice. Don't take too much of trouble. Don't panic. Use seminar package sufficient for publishing. Yes. Okay. Yes, Kiran, go ahead. Yes. Kiran, go
Sir,
ahead. Yes.
if suppose, yes, sir. So suppose if model 1 is what I have hypothesized, but I'm getting model 2 as better model fit. So in that case, do I go and change my hypothesis? I mean, should I
No, no,
include
no,
new
no. That is
hypothesis, or
harking.
should I
No,
just
no, no.
interpret that what my
No.
model?
See, you should always report the fact. Let's say if you say that model one
Okay.
is, see, if your goal is to see, normally researchers don't keep model comparison as the goal. Felix, I'm coming to you. Felix, sir, I'm coming to you. So see, people don't keep model comparison as their goal. Yes. But let's say if you have a hypothesis where you're comparing the model, then you can't go and change back your hypothesis normally, which many people do. Now, in research, this is known as harking. Harking means changing the results, means hypothesizing after knowing the results. So if after
Okay.
knowing the result, you are changing your hypothesis, this is known as harking. You should not do it. If you are a genuine and authentic researcher, you will say, okay, data is favoring the model 2, and simply report and leave it and write few lines about model 2. That's it.
Okay.
Okay, Felix,
So,
sir, go
sir,
ahead. Yes, Kiranji, go ahead.
so
Go ahead.
one,
Ah.
sir, so if I'm going for model comparison, so do I need to have one hypothesis separate that this one of the goal of my research is to compare different models?
See, you can take it as an objective. You can take it as an objective. But
Okay.
and you can also say that that model will see when CVPAT we got the null hypothesis. No, so you can definitely conceptualize. But normally, Kiran, to answer you, I have not seen many researchers, even senior and seasoned researchers, keeping model comparison as their objective of research. But yes, you can go and hypothesize that model one will have a better. But if your goal is model comparison, and read that Leningard paper, that Lingard paper 2021, it will give you a lot of idea. That Sharma et al. Paper 2019, again 2021. These are good papers, you should read it. And find papers where people have taken model
Okay.
comparison as their goal. Yes, okay. See, no harm in later on coming out with a
Okay,
model.
sir.
See, no harm in coming out and favoring that particular model which actually fits the reality better. Yes, and now you may
Hmm.
say that there is a mediation, but actually in real life there will be no mediation. So present alternative scenarios.
Hmm.
But again, it is not recommended. Paper will be rejected because if you talk about mediation, then you support moderation. Paper will be rejected. Now people say that either stick to mediation or stick to moderation. Don't sail in two boats. Don't sail in the boat of mediation and moderation. Take one and stick to it and go ahead. So if you sail in two boats, might be some reviewers might not take it in a right way, and they will reject it paper. So stick to one gun, whether mediation or moderation. That's it.
Okay, sir.
Okay. Okay. Felix sir, go ahead. Yes.
Good evening, sir. Sir, in the BIS Akaiki weights, should we see that model 2 is having lower values, so
No,
model
no,
2
no.
is
No.
better?
See this BIC Akaike weights. You should go with that model which is giving the higher value. So higher value is 0.9035. See my cursor. BIC is favoring model 1 and Akaise is also favoring model 1. Yes. Akaise should be higher, BIC should be lower. Remember this. Okay.
Okay, sir. Okay.
So both the stats are supporting that model 1 is superior because model 1 minus 102 is lower and model 1.90 is greater. So both the models are favoring results. Both the stats are supporting model 1. So we should go with model 1.
Sir,
Okay.
in the first case, there is minus sign. So minus 93 is larger and
Yeah, yeah. In negative, it is inverse. I'll tell you, Velekji, I wrote one paper and I sent it for, I didn't send it for journal. And I thought that this minus 102 is bigger. And which one is smaller? Model 2 is smaller. I interpreted otherwise. Because then I read, no. In minus, it is reverse. Minus means the greater is smaller. In minus, the greater is smaller. So minus 102 is smaller than 93 and 97. So even I did this mistake. So in one of my papers. By the way, that paper is in UGC care. I removed that model comparison. I conceptualized a moderation model. Then I wrote in favor of mediation model. Then I sent it to a review. Somebody said, no, you can't take two stands. Stick with my either mediation or moderation. Then I removed the mediation part and gone for the moderation. And the paper is published in UGC care now. Okay. So let's do one thing. Let's take a break and we'll be back by 8 o'clock. Till then, energy will be left in me. Yes. So let me.
सर
Yes,
एक
go ahead. Go ahead. Yes.
मुझे
Yes,
सर
Sonam.
मुझे ये पूछना था कि ये जो हम मॉडल कंपैरिजन कर रहे हैं we did this with conceptualizing the relation different relationship like once it's a mediation and another in its moderation लेकिन जैसे कि हम मॉडरेशन में हम करते हैं कैटेगोरिकल में करते हैं से फॉर एग्जांपल मेल एंड फीमेल का कर रहे हैं तो क्या वो भी मॉडल कंपैरिजन है लाइक व्हेन वी आर रनिंग इट
Yes, definitely. Yes,
one for
definitely.
female
Yes. So you can have a male model and you can have a female model, but वो sense नहीं make करेगा. You can't compare a male model से. हाँ, you can say that for male see normally multi group के लिए कोई ये model run नहीं करता है, model comparison नहीं करता है. For multi group people don't go model comparison. In fact, I think you were there or not, but I did talk about multi group moderation. You were there, Sonam?
sir I joined late today so I'm still
So
confused what we have done so
no,
that's
here
why I'm asking
you focus on the video. Here we did talk about moderator, that is continuous moderator and categorical moderator, and we performed MGA. We performed MGA also. But
multi-group analysis okay
so you'll get the video. You just focus on that. But a model comparison in multi-group analysis, it will not make sense. It will only say, okay, this data is fitting for males, not for females. But multi-group analysis, you should see the difference in the beta coefficients for both the groups. That's it.
Actually, I got confused. I think now I'm clear with this that multi-group analysis is different and this model comparison is different.
Yeah.
Okay.
Kiran, go ahead.
ठीक
Yes.
है.
Kiran, go ahead. Yes.
So for this multi-group analysis, do we again have to have hypothesis initially, or we can just
You can have. But normally people don't hypothesize for multi-group, or they will say there exists a significant difference for male and female as far as purchase intention is concerned. The hypothesis will go like this. You can hypothesize, Kiran. There exists a significant difference for male and female as regards to purchase intention.
Okay. So, sir, in case if we don't have it, where should we include this multi-group analysis? Should we discuss it in where we report control variables, or should we separately discuss about this?
See, it's up to you. If you read that IMB review paper, there they have used controls, age, gender, experience. But they are not checking multi-group analysis for age, gender, experience. They are checking multi-group analysis for some other construct. So let's say if you have taken control as if you have controls in your model, then don't go and check for multi-group analysis, Kiran. Very good question, Kiran. Let me appreciate you. It's a very good question. So let's say you have taken control. You have control for gender. So when you're controlling for gender, no longer required to go again and check for multi-group analysis.
Okay, sir.
Yes.
Thank you.
Okay.
Yes.
Okay. Any other questions?
Sir,
Okay.
suppose
Yes,
Sir,
past literature says that there are certain variables that are being constantly influencing. Can we take those as a control variable? And
yes, confounding variables. These are known as confounding variables. They spoil the relationship between two constructs. So if literature talks about confounding variables, definitely you should include that as controls, Felix.
Okay, sir.
Sonam, go ahead.
sir, my question is similar kind of like जब हम MG कर रहे हैं मल्टी ग्रुप एनालिसिस कर रहे हैं and when we are applying moderation a categorical moderation of male and female so now it is same or अभी भी यह different होता है
See,
MG कर
multi-group
रहे हैं और जब
analysis,
कर रहे हैं
Sonam, multi-group analysis is checking for when you say multi-group analysis, you do it for categorical moderator. You multi-group analysis essentially makes you understand that whether significant difference exists between groups or not. let's say male and female are there. So you run a separate structural model for male, and then you run a separate structural model for female, and then you calculate p-value to find out whether significant difference exists or not. Okay. So now I'll
Okay.
upload the video. You just focus on the multi-group part. It's in detail. I've
Okay.
given explanation.
Okay.
It will make a lot of sense to you.
So,
Okay.
sir, just last question. I'm sorry. Sir, so if we are doing multi-group analysis, that means the variable is changing along with the construct or is making some changes in the construct. So that variable cannot be used as control variable, right? Because
See, first of all, normally multi-group analysis is done for gender, categorical variable. So when you are controlling for categorical variable, then no longer required to check the multi-group analysis of those. Don't do two things at a time. So either
okay.
you don't control and check for multi-group analysis. Yes. It depends upon you. If you're controlling, then don't go for multi-group analysis. And if you're not controlling, then you go for multi-group analysis.
Okay, sir. Like for example, in my situation, there is age and team size which is constant. So this I have taken as control variable. Whereas gender, work experience, these two things are changing, and therefore I'm going for multi-group analysis. So is it correct?
See, first of all, definitely gender is going to change from person to person. So if something is changing, that should not be considered. See, of course, variables are going to change, but that will not. See, first of all, please understand when do you run multi-group analysis? See, when you want to understand, or see, again, I'll tell you. When I was testing my model, so females were behaving differently and men were behaving differently. So if you have certain understanding based on a literature review that men and women behave differently, yes, for this particular relationship, then it is wiser to go and check for your data.
Okay.
Simply don't run multi-group analysis for the sake of running it. Multi-group analysis tries to factor the differences between the groups that are present. Okay. So
Yes.
as regards your team size and all, so you can definitely check a multi-group analysis for largest team size and smaller team size, the relationship. So if you read this paper again, the paper that I talked about it, this paper, here, see, here, if you focus on this paper, they have used, just pay, I think my screen is not shared. All of you just pay attention. Let me share the screen. Let me take this question. It's a very interesting question by Sonam and Kiran, and all of you just pay attention. See, here the authors have controlled for lot many things. They are saying we control for age, gender, and experience. So they have control for age, gender, and experience. Yes. So later on, they did not perform multi-group analysis for age, gender, and experience. But now, if you focus here, here they are given some arguments that why they perform multi-group analysis. Let me show you that particular part here. In addition, we performed MGA to test whether power distance across two groups. Now there are power distance, low power distance and high power distance. So one group which is having low power distance, and how do you understand power distance? Now I'll tell you, in my previous work, some people had very easy access to the leader. Some people, they were not allowed to meet the leader. So here you see there is power distance. This is how I understood. So low power distance and high power distance. So high power distance, maybe they have to take permission, they have to write mail, then the leader will meet them. And low power distance means people straight away can go and meet the leader, call the leader, talk to him on phone. But that facility is not available to. So here the authors have gone ahead and checked MGA for low and high power distance. They have not checked MGA for age, gender, and experience. Getting, Kiran? So try to see your controls and MGA should be different if possible, Kiran.
Okay, sir.
Okay.
Yes.
Sir, controlling का तो simple meaning यही हो गया ना, that we are not checking the impact of that factor, तो comparison तो फिर वहाँ पे करना ही क्या है उसका.
When you're controlling, there is no point in checking the different effect over there. So I think what I answered to Kiran, the answer applies to you also. Okay. So now we'll take a model where I will be bringing controls. After this session, we'll take a very complex model. Okay. So let's do one thing. Let's break As of now, let's break it. So let's meet by 8:15. Yes, 8:15 we are back, and we'll take a very complex model. And I request all of you to be in the class. We'll take a very complex model. It will make a lot of sense to you. So let's
Sure.
meet. Let's meet by 8:15. Hello, hello, hello. I think 5 minutes
Yes.
are there.
Yes.
Let's start after 5 minutes. I think I tell it 10, 8:15 I said, no?
Yes.
I should have told 8:10. By mistake, I said 8:15. Hello, everyone is there? Shall we begin?
Yes, sir.
Okay. What about Shilpa? What
Yes, sir.
about Hemant, Felix, Deepali, Aditya? Kiran
Yes.
is there, of course. Should we begin? Should we begin? Okay.
Yes, sir.
So tomorrow you should see the attendance. See, we started with 22, then first, second day it was good, third day was okay. Now you see fourth, fifth day. Tomorrow you'll find that only 5, 6 people will remain. By the way, all are serious people. All those people who are there right now in this group, they are very serious and they want to learn. Okay. Uh, let's begin. Let's begin. Let me share the screen and we'll test a very complex model, which is the purpose of this particular workshop. Okay. So, yes. Uh, Now everyone pay attention. Everyone pay attention. Yes. Okay. So, okay. Just a second. What is happening? Yes. Now friends, pay attention. So we are going to test a complex model. All of you pay attention. Huh? Yes. So let me specify the model. Let me specify the model. Okay. All of you just pay attention. So I'm taking a model, yes, where LMX is my independent variable. Yes, again, it's an OB example, so bear with me. Yes, and then there is another variable which is known as PSYCAP. Okay, that is known as psychological capital. Third variable is organizational identification. And fourth variable is, let's say, yes, fourth variable is performance. Okay, and which has two components. One is in-role performance, and next is extra role performance. So what I'm going to do, I'm going to test this particular model. Yes. Okay. Now you can see there are two mediation in this model. So this is a case of a sequential mediation. So let me write here. It's a sequential oblique serial mediation model. Serial mediation model. Okay. So there will be one path from LMX to OI, and there will be one path from PSYCAP to performance. Now, friends, just pay attention. Let's identify the direct paths in this model and the indirect paths in this model. Please bear with me. My writing is not that great while I write in this way. So can you identify direct path? So let us identify direct path. Friends, all of you pay attention. Yes. So there is one path from LMX to PSYCAP. LMX to PSYCAP. Yes. Okay. Then there is one path from LMX to OI. Then there is one path from LMX to
Performance.
IRP. Let's divide performance into two. ERP. Yes. Then there is one path from PSYCAP to OI. Yes. Then PSYCAP to ERP. IRP. Sorry. Then PSYCAP to ERP. ERP. Then there is one path from OI to IRP and one path from OI to ERP. By the way, performance is measured using two dimensions. One is your in-role performance and second is your extra role performance. Okay. So now you focus 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 direct paths. And now let us see how many indirect paths are there. Indirect path also will be many, but let's reduce to few one. So one path is from, let's say, first let's start from LMX. So let's say LMX, PSYCAP, IRP, then LMX, PSYCAP, ERP, then LMX, OI, IRP, in-role performance, and LMX, OI, ERP. See, there are many. There could be PSYCAP, OI, ERP, PSYCAP, OI, IRP. There are many. But let's restrict to 4 paths. Let us check 4 paths. By the way, there could be many. PSYCAP, OI, IRP, PSYCAP, OI, ERP. If you want, you can take that also. Let me erase this then. Let me take a few more paths. It's a very complex model. Huh? Then let's talk about PSYCAP, OI, IRP, then PSYCAP, OI, ERP. Yes, so there are 6 paths. So if you focus on this model, there are total 15 paths. There are how many paths? There are total 15 paths, out of which 9 are direct and 6 are indirect path, direct path and indirect path. Okay. Now to make the model complicated, let me include the control variable in the model. So I'm including the control variable in the model. Controls. So I will control for gender, I will control for age, and I will control for experience. So this model I'm going to test. By the way, I'm working on this paper, so I thought of better sharing with you. Okay. Hope all are there in the class. Now, friends, all of you just pay attention. This is the syntax higher order models. It is shared with you. Higher order models syntax is shared with you. Just open the G Drive folder, download it and bring it in your RStudio. Yes. Okay. See now how I'm doing it. Again, it's 5 steps. I'm using the seminar package. Then this model I will also test using CSUM package and we'll compare the results. and we'll compare the results, the results will almost be same. Means 99% result will be same. Okay. Now here see, again we are going to use the D data file. By the way, D data file is already imported. D data, yes, you can just check it. So this is the D data file which I'm going to work on it. Yes, okay. So first composite LMX, it's a multi-item. Values are from 1 to 7. Again, now friends, focus. This OPSEHOE, this is a higher order construct. Yes, okay. So if I can go here, friends, all of you just pay attention. All of you just pay attention. So PSYCAP, it is a higher order construct and it has 4 dimensions. It has 4 dimensions. Okay. So first dimension is hope. Then hero. Hero means self-efficacy, E. So there is self-efficacy. Then there is resilience. And then there is optimism. Yes. So now the question persists, friends. When to conceptualize a higher order model? Question is when to conceptualize higher order constructs or higher order model. Yes. Now, any guesses? When should you go for higher order constructs? Yes. Now, friends, please pay attention. There are a couple of thumb rules. First, if the literature says so. Now, if you read the work of PSYCAP, now Luthans, somewhere in 2004, he conceptualized a new construct which is known as PSYCAP. Yes. And he said that PSYCAP has 4 dimensions and he used the framework, hero framework. Hero. So he said H stands for hope, E stands for self-efficacy, S is in the bracket, R stands for resilience, O stands for optimism. So this together hero, they make up PSYCAP. Okay. So when should you conceptualize a higher order construct? First thumb rule is literature. Let's say the objective of your study is to understand the effect of PSYCAP on other variables. Yes. So definitely you have to take PSYCAP. Now, when you take PSYCAP, you will use the measure which has been developed by the author, or the author must have came out with the operationalization, and the author must have came out with the scale. So let's say if the author has conceptualized that scale as a higher order construct, you also can conceptualize it as a higher order construct. You can cite literature. Luthans conceptualize PSYCAP as a higher order construct. So following Luthans, the present study conceptualize PSYCAP as a higher order construct. Very easy. Just cite the literature. Second is, if there is a discriminant validity issue. If there is a discriminant validity issue. Now there are a couple of people, they simply don't conceptualize a construct the way the original authors have conceptualized. They use certain statistics, they use certain measure, and if they find that okay, this hope, self-efficacy, resilience, optimism, there is discriminant validity issue, then they say then to overcome the discriminant validity issue, they go and conceptualize the construct as a second order construct or a higher order construct. Just remember this. So there are 2 grounds on which you can conceptualize a construct as a higher order construct. First is the literature says so, the author says so. Second is if there is discriminant validity issue. Now let's say the relationship between hope and self-efficacy. Let's say this is hope and this is self-efficacy. If the R between them is let's say greater than 0.70. See, discriminant validity concerns comes into picture if R is very high. If 2 variables have very high correlation among themselves, it means people who are answering these 2 variables, they are not discriminating between the 2. They are seeing both the construct as one construct. So when your R goes high, automatically it is an indication that discriminant validity will be violated. See, discriminant validity violates when people don't discriminate between the items. Yes. When people don't discriminate between the items and they see every item to be 1, then in that case, discriminant validity will be a concern. So please note this, that when discriminant validity is a concern in the lower order constructs, then you should conceptualize PSYCAP as a higher order construct. Yes, okay. So we'll talk about this when we test the model. Now, I want all of you to focus on this particular syntax. So here you see LMX is a first order construct. First order construct. It has no dimensions to it. But when you talk about PSYCAP, it is composed of optimism, self-efficacy, hope, and resilience. So here I am measuring all the 4 dimensions. And in the original file, if you focus on D data, if you focus on the D data file, here you see the name is PCOP1, PCOP2, PCOP3. Yes, it is given. So here you should be very specific. Here you should write the name of the column which is there in the Excel file, and just give the number from 1 to 4, 1 to 5, wherever it is. Let's just locate it, and then you will write another syntax: higher underscore composite. By the way, this is a, let me erase this upper arrow key. This is a function. Higher composite is a function. Yesterday, Love sir was asking when that please show us a model where there is a higher order construct. So for higher order construct, this is the command, and the syntax is given. See, syntax they have given it. If you focus here, they have given the syntax. So higher composite, quality, and quality is comprised of this, and method is 2-stage. By the way, the method is 2-stage itself. By default, it is 2-stage. You need not write it. So this is higher composite. Yes, and then just write OI, ERP, IRP, and then I'm modeling age, experience, and gender as controls. If you remember, in this complex model, I'm modeling 3 demographics as controls. So in the measurement model, go and define those constructs. Say age, it's a single item and measured using age. Experience, again, it is a single item measured using experience. Gender, again, it is a single item measured using gender. Just define all the items that are going to be there in the model, along with the independent variable, dependent variable, as well as controls. Whatever is there in your model, just go and write in the higher measurements, and just provide in Excel where do they lie. Just give the fit the column accordingly. Okay. Then create the structural model. Now all of you just interpret the structural model very deeply. So this is a vector higher structural model. Relationship is a function. Start with single colon. Paths from. So first path is from LMX PSYCAP. So from LMX PSYCAP to OI, ERP, IRP. So LMX and PSYCAP, they're connecting to OI, ERP, and IRP. Then there is a path from OI to ERP, IRP. There is a path from OI to EIP, ERP, IRP. And then there is a path from LMX to PSYCAP. Also path goes from LMX to PSYCAP. So from to. So from means from where is the path going, and to means where it is heading, where is the position of the arrow. And lastly, just use the controls. So control is from gender, age, experience. And where are we putting the controls? The control should be on the dependent variable. Don't put control everywhere, put it on the dependent variable. So there are 2 dependent variables. One is ERP and second is IRP. ERP stands for extra role performance. Extra role performance is OCB. What is OCB? OCB is that part of your job which is not written in your job description. You go and do for the betterment of the organization. That is ERP. And IRP is your in-role performance. In-role performance. By the way, if you see IRP, it is measured using a single item. Single item. I have simply asked what was the performance rating that you got in your previous appraisal. Simply ask one question. What was the performance appraisal that you got in your previous appraisal? So people will say average, below average, par, satisfactory. People will write. So it's measured using one item. Okay, very simple. Now, what we will do first, let me erase this part and slightly increase the console window, because now the play is of console. So now first run this measurement model. Okay, and if you want, you can plot this measurement model and check whether everything is fine or not. So higher measurements. Yes, okay. Now, if you focus this, now again, this is your seminar package on which you are practicing right from day one. Here you see gender, experience, age. Then again, these are all gender, experience, age are measured using one item. IRP measured using one item. ERP measured using 8 item. OI measured 5 item. Then you see PSYCAP is conceptualized as a higher order construct. See the diagram of the PSYCAP. SciCap has 4 dimensions. Then lastly, LMX. Okay. Structural model appears to be fine. Now let's do one thing. Let's run this particular model or structural model. Okay, structural model, we have ran it. Now let's plot the structural model. PLOT plot. What's the name of the structural model? Higher structural model. This is the name of the vector. Can you see the diagram, friends? The beauty of seminar package. Seminar package is known for its simplicity. See, is the diagram correct? So there is path from LMX to SciCap, SciCap to OI, OI to IRP. Yes. Then from LMX to OI, then LMX to ERP, and LMX to IRP. By the way, every path goes from LMX. See, maximum arrows are being shot from LMX. And most of the arrows are coming to IRP and ERP. And see, all your experience, gender, and age, even they should be connected to both the dependent variable. So by the way, we are testing a very complex model, friends. We are testing a very complex model. Okay. Now we are not behind simple models. So there are 9 direct paths and there are 6 indirect paths. Total 15 hypotheses we are checking through this particular model. Yes. Okay. So, okay. Diagram is okay. Fine. Everything is okay. Now estimate the model. Let's estimate the model. So all 99 observations are valid. Summarize the model. Okay. Summarize the model. Yes. And if you simply take this and run it, you will get all the R square and beta value, all these things. And you see, now focus on the reliability. Yes. Okay. So LMX reliability is good. SciCap again, it is a higher order construct. Reliability is good because SciCap we are seeing it as a higher order construct. Yes. Okay. Then OI is also decent, and see the alpha for OP, see the alpha for SE, see the alpha for HO, see the alpha for RE. If you can make sense, the alpha for OP is very less. Actually, Cronbach alpha should be greater than or equal to 0.70, but here OP it is very less. Why? Because there is one reverse coded item in the optimism dimension. So whenever there is a reverse coded item, you should go and rerun it, delete that item and rerun it. But doesn't matter. My overall SciCap reliability is good. It is of no concern to me. Okay. Yes. Okay. So then this is my composite reliability. Again, this is fine. AVE. Check for main construct. AV for LMX is good. AV for SciCap is good. AV for OI is good. AV should be greater than 0.50. Then again check AV for ERP. There is a problem. If you focus ERP, AVE is a problem. Why it is problem? We'll check the loadings. So wherever loadings are lesser, we will delete that. And we will again rerun the operations. Yes, so there is a problem in ERP. ERP ka AV mein problem hai. It is not greater than 0.50. It means there is a convergent validity issue. Now we need to drop certain items in LMX, ERP and rerun it. Single item we don't see convergent validity. And here see rest convergent validity is established. There is a problem only in ERP. Okay. Yes. So if you want, you can check the loading also. Let me check loading hai kya. Dollar. Yes. Let us check the loadings. Check the loading of particularly of ERP. Where is ERP? This is ERP. OCB. Yes. And here you should check. No, here it is. Here. Here, if you focus, friends, see this loading should be greater than 0.708, and there is a problem in OCB1 and OCB2. See the OCB1 is 0.524 and this is 0.593. So what you should do, you should simply remove this. So let me show you how to remove it. All of you just pay attention. Now I'm doing everything simultaneously. So let me remove, there is a problem in ERP. So 1, 2 is problem. So I'll simply make it 3, 4, 5, 6, 7, 8. Yes, I simply went and changed it. And now let me rerun it so that the AV improves. Now you see AV will improve. Run. Hope everybody is prescribing. Hope everybody is understanding what I'm doing. Yes. Okay. And simply summarize the model. Now you see, friends, the AV of ERP, it is improved. Can you see? The AVE of ERP is now improved after deleting 2 items. That is OCB1 and OCB2. So when your AV is a problem, you should check those indicators which have loadings lesser than 0.70. Yes, if you drop it, automatically AV will improve. Hope it makes sense. Hope it makes sense. And here also, let's say if I want to improve the reliability of OP, this reliability is less than 0.70. What I'll do in optimism dimension, I remember the 4th item is a negative worded item. So if I make it 3, I'm changing here. OP is a 4th item is a negative worded item. You see, even this will improve. The reliability of this particular improve. But that should not be my goal. But still, I'm doing it in order to make you understand how things are done. Run, estimate the model, summarize. Let's say summarize the model, and let me do this. Friends, all of you pay attention. See what is happening to OP. Suddenly the reliability improves because there was one reverse coded item, and reverse coded item normally people don't answer it very properly. So delete that particular item, automatically your reliability will improve. See here, everything is a perfect picture. Yes, and which is your main dependent variable? Main dependent variable is IRP and ERP. So all the variables together are explaining 59% in ERP and almost 34% in IRP. These are beta value and all those things. Now let's bootstrap the model. See how I bootstrap the model. Again, this step you know how to bootstrap the model. Huh? So what I'll do, I'll simply run this line number 39. Yes, the model is getting bootstrapped. Okay. Now we'll summarize the bootstrap model. Again, it's a mechanical step. You can run it. Okay, and simply run this summarize bootstrap model. You see. Okay, now friends, let's see the direct path. Let's see the direct path. So results from bootstrap sample, 100 samples we have generated. So LMX to SciCap, significant. LMX to OI, significant. LMX to ERP, it is not significant. LMX to IRP, yes, significant. LMX to IRP, it is significant. SciCap to OI, you can just interpret all the direct effects which are significant and which are not significant. Yes, okay. So how many paths are there? Just count 1, 2, 3, 4, 5, 6, 7, 8, 9. Nine paths are there. This up to here there are 9 paths. Then there are paths from gender. You see, now pay attention. Somebody was talking about confounding variables. I think Felix sir was talking about confounding variable. Now, Felix sir, pay attention. Gender, age, and experience. None of your variables are significant. None of your variables are significant. It means gender, age, and experience, their effect on the dependent variable, that is ERP and IRP, is not significant. Very nice picture we are getting. Then this bootstrap weight you should see for formative constructs. So there are no formative constructs, so I'm not going to see this. You should check loadings. Yes, Kiran, go ahead. Yes.
So not if the result is not significant, that means they are not able to bring any changes in the DV, right?
Yes. No. Result. See, result you should interpret construct wise, Kiran. Focused on LMX and SciCap. This is significant. You're talking about this confounding variable gender and all.
Yes. Sir.
It means their effect is not there on the dependent variable.
Okay. And if it would have been significant, that means
then you should have gone and said, okay, that gender has an impact on ERP and IRP. Then you should go and write about it.
Okay. Thank you, sir.
Okay. Then bootstrap weight, you don't focus in reflective construct. Loading, you should focus. You see, this one has a very poor loading, LMX1. But again, the confidence interval is okay. See, you should not remove only one item. If AV is greater than 0.50, just retain. And by the way, see, all items are greater than 0.708. You see, even there is a problem here. This is less than 0.708. So you can delete this item and delete this item. Automatically, AV will improve. But anywhere AV is decent for LMX, no problem. Then, yeah, okay. So all the loadings are quite good. No problem with the loadings. Here you can see problem OCB6, there is a problem. But again, I'll not remove it because OCB1 and OCB2 I have removed it. Yes, okay. This is Bootstrap HTMT. Again, it is, you see Bootstrap HTMT, and now just pay attention. Bootstrap HTMT. Here you see, wait, where is Bootstrap HTMT? Yes. Here you see SciCap, OP. Here see the Bootstrap is greater than, here you see OP, SE, HORE. These are dimensions of SciCap. And here see they are greater than 0.85. So here discriminant validity is violating. Itself suggesting that actually this OP, SE, HORE, they are together making up SciCap. Okay. So then this is total path. Total path, see, now let's interpret total path. So LMX to SciCap, it's significant. Means the first arrow from LMX goes to SciCap, that is significant. Actually, LMX to SciCap, this total effect is itself is a direct effect. Then LMX to OI. LMX to OI means in between there is SciCap. So mediation is significant. See, LMX to OI means between LMX and OI there is one SciCap. So this is the total effect and this is significant. It means SciCap mediates the relationship of LMX and OI. You can simply make out from the total effect. Then LMX to ERP. LMX to ERP descent means all the means there is a sequential mediation. See, LMX to ERP. So first arrow from LMX to SciCap, SciCap to OI, and OI to ERP. When total effect is significant, itself you should understand, yes, there is an indirect effect. Okay. Then LMX to IRP, again, this is significant. So just interpret all those things. Now let's calculate specific indirect effects. You know, there are 6 mediations. So first mediation LMX SciCap OI. Let's interpret this. Hope everybody is understanding. Hello.
Yes, sir.
Anybody is having some issue, not able to understand? Because see, this is mechanical. This is what we have been doing in the past 4 days. So that's why I am slightly going fast. But you should have no problem in interpreting the results.
Sir,
Yes?
Yes, sir.
And OI, since the total path is not significant, the last one, can we say that SciCap is not a mediating variable between
Which one, sir? Which one?
SciCap leading to OI?
See,
Since
no, sir. So SciCap OIC. Sir, see this diagram. See this diagram, sir. Just a second. So SciCap OI, straight away the arrows going from SciCap to OI. So it's a direct effect.
yes, sir, it is not significant. Then we can say it is not a mediating between LMX and OI.
We can say SciCap and OI, this is not. It means SciCap and OI is not significant. The total effect is not significant. But by the way, Felix G, simply looking at total path, you should not comment on mediation. You should check specific effects. Yes. Okay. If you remember this command, we saw it. So let's check one by one. We'll check 6, 7 mediation. We'll check all the mediation. Huh? So let's check whether SciCap mediates the relationship of LMX and OI. So we'll check this. Huh? So Felix G, pay attention. Huh? Simply by looking at total effect, you should not comment. But if you want to check specific indirect effect, then use this command. So specific effect significance, bootstrap higher model from LMX through SciCap to OI. So from, through, to, 3 prepositions are there. Run this. Is it significant? No, it's not significant, Felix. Felix, it's not significant because why? SciCap to OI path is not significant. Yes, you see, this is not significant. It means there is no mediation. We will say SciCap does not mediate the relationship of LMX and OI. Then focus on this LMX SciCap IRP. Again, this is not significant. LMX SciCap IRP. Then LMX SciCap ERP. Run this. This is significant. It means SciCap mediates the relationship of LMX and ERP, but not with IRP. And focus on this 68. LMX OI IRP, significant. OI is very important. Huh? OI is very important. Okay. Then LMX OI ERP, this one. Again, this is significant. Again, this is, see the T-stats and see the confidence interval. This is significant. Okay, so we checked how many we checked? 1, 2, 3, 4, 5. 5 direct effects we checked. Huh? Now let's check the indirect effect. Now let's check sequential mediation. Sequential mediation, when I say, it means LMX, SciCap, OI, ERP, and then LMX, SciCap, OI, IRP. See how to check serial mediation. Huh? So from LMX through, in the bracket, right, SciCap, OI to IRP. So let's check this. Significant? Not significant. This is not significant. Yani, the sequential mediation of SciCap and OI is not there in LMX and ERP relationship. But if you focus here also it is not there. Means sequential mediation is not there. By the way, I have given you only 99 data. My data is 268. So I've just extracted 99 data and gave to you. But if I run on my data, I'm getting many things significant. Yes. And if I can show you the paper where I have reported, yes, see the paper I have reported it. See my friends, LMX, SciCap, OI, ERP, this is supported. And LMX, SciCap, OI, ERP, this is supported. So when you take a larger data, many things will be supported. So if you focus, all my 9 hypotheses are supported with a larger data except SciCap and IRP. And here, SciCap, LMX, SciCap, IRP is rejected. So out of 16 hypotheses, my friends, 14 hypotheses are supported. 14 hypotheses are supported. If you work with a larger data, Yes, hope it is making sense to all of you. Yes.
So,
Now,
sir,
yes,
sorry,
yes.
sorry, sir. So, sir, the path which is not supported, we have to justify that with some
Yes, in
literature.
the discussion section, you should justify. In the
Okay.
discussion section of the paper, you should justify, you should write that if certain paths are supported, what is the significance, and if certain paths are not supported, why they are not supported. So let's say
Okay.
SciCap IRP is not supported. One justification I can write that IRP is measured using a single item.
Right.
Actually, mainstream literature, Kiran, mainstream literature talks about that SciCap and IRP are supported. But in my study, it is contrary. Now here I have to give justification for it, that why in my study, SciCap and enroll performance is not supported. So here I need to go and write about my scale, that maybe in limitation also I should write that IRP is measured using one item. Actually, it should have been measured multi-item. And
Okay.
IRP, I have asked from the respondent itself. IRP, I should have asked from the supervisor. So whenever you are collecting your data, see that some constructs are answered by respondents and some constructs are answered by other person. So I could have measured LMX from the leader's perspective. I could have measured performance from the leader's perspective. If I could have asked the leader, how is your colleague doing? He would have given the rating. That would have been a more valid measure than asking a respondent to give him his rating. Now, normally people conceal. No, if you ask somebody's age, people definitely will conceal. If you ask people that why they left their previous organization, definitely they will conceal. So it is always better that some construct you should ask from the respondents, and other construct you should ask from the leader or from the colleagues or from other members of the organization. This is what
Okay,
it is
sir.
suggested. Okay.
Sir, it could also be possible that theoretically, it is not only LMX, but organizational support, how much is perceived by the employee, also plays a.
See, first of all, organizational support will be there. See, first of all, it is correct. There is no wrong answer, because in social science, there are many realities. Now, Kiran, please pay attention that, let's say, if the first of all, leader is the organization. Please remember this. In India, at least I
Okay.
can talk about. In India, leader is the organization. So if leader
Okay.
supports you, that will be seen as a larger support. Okay.
Okay.
So that's why you can go and argue that most of the organizations are run by leaders, and leaders take a call, they control everything, they have resource in their hand, and that's why people see the organization from the lens of a leader. I said,
Okay.
no, I worked with 2 organizations and I always had issue with the leaders. मेरा जमता नहीं था उनसे. Particularly, sorry, I should not say this is recorded and it will go on YouTube. Somebody will do data mining and say that. So, but, I always like, they never made sense to me, particularly. Again, this is with 2 or 3 organizations, not with many. Others organization will be good. But I could not make sense in their actions, in their behaviors, and in their attitudes. I never make sense. So, by the way, you should watch this movie, The Helen of Troy. The Helen of Troy, in that there is one Achilles. There is one person, Achilles. So he never fights for the king. He said these kings, they live a lavish life and they make ordinary soldiers fight in the war and they shed the blood. So I don't fight for the king and his luxury. I fight what is right and I fight what is good. So I fight for justice. So there's a beautiful movie, by the way, The Helen of Troy. It's a wonderful movie. It's action, comedy, romance, everything in one movie. You should definitely watch The Helen of Troy. And Achilles says that I don't fight for king. I'm not saying I'm Achilles, that I don't work for leader. Okay. Now, friends, measurement model over, structural model over. Yes. By the way, can I plot the result? Yes. Let's plot it. See how the plot looks. So can I? Yeah. If I can just plot it, PLOT plot, and let's put this in the bracket. I'll get a very beautiful diagram, very big diagram, and this diagram will make a lot of sense to you. Is it plotting? See, there's a blip line. Okay. See, friends, this is the complex model. Lavji, please check. Lavji said, please take a higher order construct. Now here you can
actually, by looking into the graph itself, it is a very complex, sir.
By the way, model should not be too complex, huh? Because then you don't explain the reality better. But here you see LMX to PSYCAP path is significant. LMX to OI is significant. But PSYCAP to OI is not significant. So when PSYCAP to OI is not significant, automatically from PSYCAP to OI, all other routes are blocked. That's why both the serial mediation are not significant. Why? Because PSYCAP और OI का रास्ता ही ब्लॉक हो गया है. अगर PSYCAP और OI का रास्ता नहीं खुलेगा तो आगे का रास्ता कैसे बढ़ेगा? That's why in 99 data set, both the serial mediation, both the sequential mediation results are insignificant. Why? Because PSYCAP to OI path is not significant. Yes, okay. But you see OI, you see one variable OI. If you can make people identify with the organization, forget about what is there up. इधर से देखो LMX to OI, OI to IRP. And OI mediates the relationship of IRP and ERP. That's why you should improve the quality of leadership in the organization and you should make people identify with the organization. So normally I have seen that if you are in the good books of the leader, no, you will definitely identify yourself with the organization. You will say that this organization is very good. See, you are good with the leader, but suddenly your words change. It changes. You start appreciating the organization. But when the leader changes, you start creeping about the organization. Why? Because leaders impact organizational identification. And if you identify, you will display extra-role performance and in-role performance. Okay. So this is how the model result appears. Now, friends, we are touching the complicated part. We are touching the complicated part. By the way, let me tell you, Felix sir was there in July 2021 when I was first teaching PLSSCM in the lockdown. And Felix ji remembers that we used only one package, PLSPM, a very basic package, PLSPM. We didn't talk about CSM. We touched, but in a very small way, not in a big way. At that time, seminar package was not there. Okay. So now all of you just pay attention. Now let's inspect the predictive power of the model. Predictive power of the model. Now you know there is a command, predictive power of the model. Simply run this. Predict PLS, estimate model, technique, predict DA, number of folds and all those things. Just run it. See what it will give. Huh? See what it will give. If you simply run it. Now, Lavji, please pay attention. That whenever you use higher order models, there is you will not get solution for PLSpredict in higher order model. It is saying there is no published solution for applying PLSpredict in higher order models. Means if you are working with higher order models, PLSpredict you can't calculate with seminar package directly. Now somebody will question you, then use smart PLS if R is not calculating. Now there is a technique. All of you just pay attention. Now what I've done, and now I'll cheat the system. Somehow, if I can convince R Studio, no, this there is no such thing called higher order construct. It is a first order construct. Then R will give me the PLSpredict, RMSE, MA. It will give me. So here I've written. Let's cheat the system. So how will I cheat the system? Now all of you just pay attention. Huh? It's a very by the way, it has this command that you see before you. It has made me slog for many days in order to estimate PLSpredict for higher order models. So now what I'm doing, see, can you see this bootstrap result here? Here there was a bootstrap result. This what I'm doing, I'm simply storing it in a vector. Yes, I'm storing it in a vector bootstrap higher order. Let me run this. Huh? Let me run this. Yes, it will give me so many things. Press upper arrow key, press $. And if you press $, you can simply extract the first order model. Yes, let me press upper arrow key, $. Construct scores. Loveji, please pay attention. All of you just pay attention. See, this is optimism. And this is self-efficacy, hope, resilience. So what I'm doing, I'll simply extracting the first order. मैं क्या करूंगा, जो लोअर ऑर्डर कॉन्स्ट्रक्ट है ना उसको निकालूंगा और उसको साइकैप में डाल दूंगा. And I will make the computer understand that no, this is not a second order construct, this is a first order construct. So I'm cheating the system. See how I cheat the system. Huh? So I'll extract this. Yes, okay. Then I'm creating construct, means my optimism will be there in this particular. So let me extract this. And if I simply type scicap1, this you can see, this is nothing but these are all optimism dimension. ये optimism के construct scores है. Optimism के construct scores है. वैसे इसके 7, 8, 9. I know it is bouncer. Then what I'll do, this line number 115 to line number 118, whatever scores that I've extracted, I will put it in the file, Excel file. And then I will import the Excel file again. See, it's a very tedious technique. I am sure it will be bouncer at this particular time. It surely will be bouncer, but go and try. See, what I've written, add the extracted constructs to the original file. Where is my original file? This is my original file. This is my original file. So in this file, I'm going to add all these constructs by simply ddata $scicap1, run. And then I will see now. See, can you focus line number 120? I am not creating higher composite construct. मैंने simply क्या किया? Lower order construct को extract किया. I extracted the lower order constructs, put it in the Excel file. And now see, I am conceptualizing scicap as 1 to 4. Now let me show you ddata file. LSD data. Sorry, LSD data. Here you see, in the file I've added scicap1, scicap2, scicap3. By the way, scicap4 I have not added it. I should add this also. And press upper arrow key. Yes, see. Friends, please pay attention. In the original file, I have added scicap1, scicap2, scicap3, and scicap4. And now when I will create scicap, I will say, okay, computer, this is a multi-item. This is not a second order construct or higher order construct. And the values are from scicap 1 to 4. So what I did, I run the first analysis, but I was not able to get the results of PLSpredict. So what I did, I extracted the lower order construct scores, took it in the original file, and then now I'm conceptualizing CVPAT as a first order construct. Hope it is making sense. Initially, here I was conceptualizing CVPAT as a higher order construct. Yes. Now here I am conceptualizing CVPAT as a first order construct. Now I have cheated the computer. I have cheated RStudio. Now there is no distinction of first order or second order, because I extracted the lower order construct score, put it in the original file. Again, I'm running the measurement model and providing CVPAT1, CVPAT2, CVPAT3, CVPAT4 as CVPAT measure. Yes. So when you do this, no, you will get the PLSpredict. Now let me run line number 120 to 129. Let me run it. Yes. Okay. Create the structural model. This will remain the same. This will remain the same. Estimate the model. Yes. Yes. Then bootstrap the model. Summarize the model. It's bootstrapping. Summarize the model. Yes. Now you see, you are getting the results. You are getting the results. The result will be same. There will be no difference. Okay. Then now focus, friends. Now I will generate model predictions. Same prediction power. I'll get RMSE, MEA, all those things. Friends, just pay attention. Huh? So I'll run line number 155. And just a second. What is happening? There is a red bleep. Things are behind. See. Can you see? Can you see the prediction matrix? Now just compare this. Now, which is the main construct? The main is, you should compare this. OCB1 till this. And this should be lower than LM out of sample matrix. I know it is slightly bouncer. Now see, this should be lower. Just compare. OCB1 with OCB1 in LM out of sample. This one is lower. OCB2 is lower. OCB3 is lower. OCB4 is lower. OCB5 is lower. OCB6 is lower. OCB7 is lower. OCB8 is lower. OCB9, this one is lower. High prediction. High prediction. Yes. High prediction. See, compare this with this. So this should be lower. All are lower. The model has high prediction. The model has high prediction. ये lower होना चाहिए ना? They should be lower. PLS out of sample should produce lower errors. So high prediction. The model has very high prediction. Okay. And then you can perform MG and all everything. First of all, ask any doubt, any observation, any doubt you have, you can ask. Let me stop here and let me take your doubts first. Are you able to understand, or is it bouncer? Is it bouncer? See, when you work with higher order constructs, no, then in that case, you can't calculate PLSpredict, because seminar will not give you PLSpredict. Then what you should do? You should run higher order model, extract the lower order construct score, put it in the Excel file, and then show it to RStudio that no, it is not a higher order. It is a first order construct. Then your PLSpredict will function. Hope everybody is on the same page. How many of you are practicing, by the way? How many of you are practicing? I'm sure many of you will not be practicing because syntax is there. Please go and run it. And by the way, keep this syntax. Tomorrow when you're working with higher order construct, and if your PLSpredict is not operational, then somehow you should make RStudio understand that, okay, extract the scores and make the RStudio understand that this is a first order construct. Your R will give the output. By the way, the developers have not spoken about this. By the way, you can write a paper. Huh? You can write a paper. And if some of you are interested, I'll show you one thing. मेरे मन में ऐसी विचार चल रहा है कि कुछ तो करे, कुछ अच्छा करे, कुछ लिखे. So what I'm doing, I'll show you one thing. One thing I'll show you. Just pay attention. Just bear with me. No, I'll take this file. Desktop. Let me see when I write this paper. I'll show you one thing. Just a second. Just a second. If we all can collaborate on this, if we can. I got one beautiful idea. No, screen is not shared. No, screen is not shared. Screen is not shared. Wait. Screen is not shared. Can you see this paper before you? You can write one paper, critical evaluation of R packages for performing PLS SEM, and you can compare these three packages. There is one research idea. By the way, many people are short of idea. They take topics which are already researched. They take knowledge topic on already which knowledge is created. Yes. Now you can write two research papers. Estimating PLSpredict for higher order construct. Estimating PLSpredict for higher order constructs in R. This is one research topic. You can take this research topic, by the way. First, this is the research topic. Critical evaluation of R packages. You can compare the three packages. PLSPM, CSEM, Seminar, and if you want, you can include SEM PLS also. There are 4 packages, by the way. There are 4 packages. So you can compare all the 4 packages. And now you know that which package has watched lacuna. And you can write one beautiful paper on this. Second is estimating PLSpredict for higher order constructs in R. Yes, if you can fine tune this seminar package, SEM in R, if you can fine tune this package, इसके अंदर कहीं पर अगर आप higher order constructs के in seminar package, if you can go and give the results of PLSpredict, that will be your contribution to seminar package. Yes, hope it is making sense. Hope friends, it is making sense. Yes, okay. So go ahead, you'll get wonderful topics. When you start working in R, no, you can write wonderful papers. Wonderful papers. Now, what we will do, the same complex model that we have tested using seminar package, now I will do using CSEM package. CSEM package. Now, CSEM package will give you what? CSEM package will give you Q square. It will give you all matrix. So let me run this. But again, here no, in CSEM package, can you see this SciCap? I am supplying the measure of the lower order constructs which I have extracted using seminar package. Again, here I am not conceptualizing SciCap as a higher order construct because in the Excel file, I have added SciCap 1, SciCap 2, SciCap 3, and SciCap 4, extracting it from the seminar package. So now what I'll do is simply run this. Seminar, this is SEM package. See the syntax of SEM package. Estimate the model, run. Okay. Then estimate the output. Very simple, very simple. SEM package, CSEM package gives fast result. Assess, run it. Now let's compare. Let's compare SEM package with CSEM package. Just a second, I'll compare. So here what we had, let's say this is assess. No, I'll put it in A. A vector, and then I'll take A and put $, and I will simply take let's say AVE. Okay, and here also I calculated AVE. No, here maybe I'm doing some nonsense. Don't get frightened. It's very easy. Practice. Simply nothing big deal about it. And if I summarize this, if I run this, now let's compare AVE of CSEM package with AVE of what? Of this seminar package. Let me even make me more simpler. Say AVE, put it B, then B, $. What do you want? We want only reliability. Okay, now compare. See the AVE of LMX is how much? 564. Here also it is 564. SciCap AV is 0.667. SciCap AV is 0.667. Same. Almost. If you reduce it to 3, it will become 668. Then COI AV 0.726. OI AV 0.726. See, same. Exact dicto result you are getting, my friends. Sonam was asking whether can I use 2 packets. Sonam, 100%. Yes, okay. Then ERP AVE. Where is ERP AVE? Here you see slightly change. Here you know why we see change? Because here I have not dropped the item. 2 items I have not dropped here. 2 items I have not dropped here. See, here I should drop these 2 items. OCB1, OCB2. Then I'll get exact dicto results. Huh? And you get dicto result, friends. Whether seminar package or whether CSEM package, you get dicto result. Don't worry about it. Okay. And see the dimension. Dimension also you can compare. OP 6.37, OP 6.37. OP is not there, by the way. See, everything is same, friends. Everything is same.
बट सर हमने जो आइटम ड्रॉप करी थी वो हमने इसलिए करी थी ना क्योंकि हमारा एवी ठीक नहीं आ रहा था उसमें।
हाँ, लोडिंग हो रहा था।
तो ये बिना ड्रॉप किए हुए सही आ गया है, इसका मतलब रिजल्ट में डिफरेंस तो हुआ ना?
सही नहीं आया, सही नहीं आया। एक्चुअली क्या है मालूम है क्या, कि OCB1, OCB2 पर मैं ड्रॉप किया है क्या? लेट मी चेक। ड्रॉप
3
किया
से
है
8 लिया था ना वहाँ?
हाँ,
ये रहा नीचे आइए, ये रहा
हाँ,
है।
किया था। बट कंपेयर करते हैं। हाँ, किया है मैंने, ड्रॉप किया है। अब कंपेयर करते हैं। OCB ये ERP है ना 0.508, और वो किधर है ये आपका ERP? ये फर्क है, देखो फर्क है सोनम।
नहीं फर्क है सर, व्हाट आई एम सेइंग इज आपने दोनों में ड्रॉप किया है अभी, ये
दोनों में ड्रॉप नहीं किया। नहीं सोनम, यहाँ पे नहीं ड्रॉप किया। देखो यहाँ पे ना मैंने ड्रॉप ही नहीं किया है।
नहीं सर, माय क्वेश्चन इज हमने ड्रॉप इसलिए किया था बिकॉज इन दैट केस द एवीई वाज, इफ आई कैन रिमेंबर, इट
हाँ,
इज
समझा।
0.8।
हाँ,
तो अभी यहाँ पर बिना ड्रॉप किए सही आ गया ना ये
नहीं
ऊपर?
अब सेम नहीं हो रहा है ना। देखो जो ड्रॉप, सी फर्स्ट ऑफ ऑल मैंने कुछ ऊपर में ड्रॉप किया, नीचे में ड्रॉप नहीं किया। अभी देखो ना, यहाँ का ERP देखो कितना है, 0.508। यहाँ का ERP देखो, चेंज है ना। क्यों चेंज
तो
है?
यहाँ
क्योंकि
पे
मैंने ड्रॉप नहीं किया है। तो
आपने ड्रॉप नहीं किया है ना,
अगर
तो जब
ड्रॉप
हम
करोगे तो
पहले
सेम
मॉडल
आएगा।
रन कर रहे थे,
ड्रॉप करोगे तो सेम आएगा, या ऊपर भी रखो सेम आएगा। देखो मैंने किसका LMX का मैंने ड्रॉप किया है क्या? LMX का
नहीं सर, आई एम सेइंग इज कि जब हम पहले रन कर रहे थे,
हाँ सोनम बोलो।
आई एम सेइंग इज व्हेन वी वर रनिंग दिस मॉडल प्रीवियसली, देन द AVE was 0.48 and we have not dropped any item because the AVE is 0.4 at 0.48.
अच्छा।
That's why you drop 2 items, 1 and 2.
हाँ,
So अगर हम पूरे ऊपर वाले मॉडल में देखें, अभी हमने ड्रॉप नहीं किया है, AVE is coming acceptable range. It's 0.5 exactly.
हाँ,
So this
ये
is what I am saying. यहाँ पर तो वो बिना उसके ड्रॉप के आ गया ना, मतलब रिजल्ट्स में डिफरेंस तो है थोड़ा बहुत कहीं ना कहीं।
हाँ, थोड़ा डिफरेंस है थोड़ा। और वहां पे भी कुछ 48 पॉइंट समथिंग था,
0.48 समथिंग था। यस,
माइन्यूट डिफरेंस है। यहाँ पे ERP मैंने ड्रॉप नहीं किया, इट्स अ माइन्यूट डिफरेंस। बट यू सी LMX का पूरा सेम आ रहा है। LMX में कुछ ड्रॉप नहीं किया है।
वो सब सेम आ रहे हैं, बट वो
इक्का दुक्का थोड़ा
प्रॉब्लम
फर्क
था,
आएगा।
वही फर्क आ रहा है बस।
0.67 ये सेम आ गया है। OI का सेम आया है। यस, ओके। ERP का कितना आ रहा है? यहाँ ERP अलग है और यहाँ ERP है। अगर मैं ड्रॉप करूँ ना सोनम, मतलब यहाँ पर, तो ये ना बरोबर इसकी तरह आ जाएगा। अगर मैं यहाँ पे ड्रॉप करूँ ना, ये दो,
हाँ, maybe it will come similar to this, but what I'm saying is we
मैं
have not
समझा।
dropped, है ना? तो उस केस में
हाँ,
डिफरेंस हो गया।
थोड़ा बहुत डिफरेंस रहेगा, थोड़ा बहुत
सर
माइनर
मॉडल
डिफरेंस।
की एक्सेप्टेंस चेंज हो गए, वहां पर we were not able to accept it, but here we can accept।
Here we
0.5
can
हो गया ना
accept.
exactly।
Yeah. I agree with you. There is your point is valid. But let me run this output, और इसको ना मैं डिसएंटिग्रेट ट्रू करता हूँ। लेट मी चेक, देखता हूँ क्या होता है फर्क। थोड़ा बहुत फर्क रहता है। यू आर करेक्ट, शी इज करेक्ट। उसने बहुत एक टेक्निकलिटी पकड़ा है सोनम ने, वो शायद हमको नजर में नहीं आती, बट शी हैज। एंड लेट मी रन दिस। मैंने थोड़ा सा इसको कंसिस्टेंट PLS लाने का कोशिश किया। ये देखो सोनम, कितना है? वहां कितना था?
वहां 0.48 समथिंग था, यहाँ 0.49 आ रहा है।
हाँ, तो मैंने थोड़ा इसका एल्गोरिथम चेंज किया है।
हम्म
इसका मैंने एल्गोरिथम चेंज किया है। अभी इससे कंपेयर करते हैं, चलो। साइकैप कितना है 5 साइकैप नहीं, ये एल्गोरिथम मैंने चेंज कर दिया, ये मैंने कंसिस्टेंट पीएलएस लगा
सर
दिया।
इट्स ओके, आई एम जस्ट आस्किंग कि वो तो हम अगर मॉडल चेंज करें तो मे बी हमारी वैल्यूज एक्सेप्टेबल रेंज में आ जाए, वी कैन प्ले विद दिस नाउ।
हाँ हाँ हाँ, या यू आर करेक्ट, यू आर करेक्ट, यू आर करेक्ट। ओके, देन इन्फर द रिजल्ट, देन प्रेडिक्ट द आउटपुट। प्रेडिक्शन देखो क्यू स्क्वायर ऑल डिसेंट, यस, एंड टारगेट बेंचमार्क भी सब अच्छा लग रहा है। ओके, एंड देन summarize will give you, but here you can't calculate in CSAM, friends, you can't calculate the special indirect effect. This is LMX to OI, means when I say LMX to OI, in between SciCap comes, and this is not significant. Then LMX to ERP, when I say LMX to ERP, LMX to ERP means LMX, OI and ERP, and this is significant. LMX, OI, ERP is significant, huh? And then SciCap and ERP, SciCap के बीच में क्या है? SciCap, OI and ERP, not significant, because SciCap OI relation is not significant. Then LMX and IRP means LMX, OI and IRP. LMX, OI and IRP, ये थोड़ा सा अब ये पता नहीं LMX के बीच में क्या क्या आ रहा है। LMX, OI and IRP, or LMX, SciCap, OI, ERP. Don't know. I think this is the case of a sequential mediation. They're not significant. And SciCap and IRP means SciCap, OI and ERP. Again, this is not significant. But here it's slightly difficult. You don't get special indirect effects. Huh? You don't get exact special indirect effects that you get in seminar package. Either thoda you have to be very cautious and interpret the result wisely. Yes, okay. So this is what CSAM package is. CSAM package is. Honestly, tell me so far what have you understood? Come on. Or is today's session more bouncer? Let me give you a flashback. Huh? Let me give you a flashback. Okay. Let me give you a flashback what we have learned so far. Okay. So this is my favorite R interface. Friends, just pay attention. So far what we have learned? Yes. We learned measurement model. Measurement model. Yes. Okay. And then we understood what is structure. Hope the screen is visible. Screen is visible? Screen is visible?
Yes, sir.
We knew how to we learned how to estimate structural model. Yes, okay. Then after that we saw what you call as mediation. In mediation, what did we see? Simple, sequential. Today we see sequential mediation. Huh? We saw sequential mediation and parallel mediation. Yesterday we ran parallel mediation. Yes. So 3 kinds of mediation we tested in this workshop. Okay. Then we saw moderation. In moderation, there are 2. One is your continuous moderation, or let's say moderation may. We also saw continuous moderator, and categorical moderator. When I say categorical moderator, this is a case of MGA. Okay. Then after that, what we saw? We saw model comparison. Yes. Model comparison, how we saw BIC, and then we saw CVPAT. Okay. And then we today tested a complex model with control variables. Complex model with control variables. Yes. Okay. Then slightly we also saw CSAM package. And seminar package, of course, we are seeing it. Seminar package. Okay. So I think we have covered a fair ground. And tomorrow, what we'll cover, just pay attention. Huh? Tomorrow we'll go for model robustness checks. Model robustness checks. Tomorrow will be advanced workshop. Okay. And here we are going to see what? Here we are going to see, let's say, first is your unobserved heterogeneity, non-linearity effects. And there is one more. What is that? What is the third one? Unobserved heterogeneity, non-linearity effects, endogeneity. Yes. Yeah, here we are going to see non-linearity effects. Then we'll see unobserved heterogeneity. unobserved heterogeneity. And lastly, we'll see what you call as endogeneity. Endogeneity. Yes. Okay. So when you learn PLS SEM, focus on these all those things. Recordings is there, and you have all the syntax with you. Please go and practice, practice, practice. And today, whatever has been covered to you, you can run it separately in your machine, in your RStudio, and see how the relationship is happening. And by the way, use CSM package also. And thoda bahut slight differences happens in CSM and seminar, but that difference is not that very big. Yes, okay. And you can still go ahead and use both the models. Okay. And it's an interesting if you can write a paper on critical appraisal of our packages, compare it with smart PLS and see which one is better. And okay. Okay. So any other query? Come on, let's stop. Let me stop and take your questions. Come on. Yes. So higher model is tested. Higher model is tested. The result is there before you. Any other thing that you think of or any other query that you have?
Sir,
Yes.
Sir, is it possible if you can, if you can provide us a flow chart, like what is possible in seminar and what is possible in CSEM, or the steps that we have to follow while we are running the models?
See, comparison is very difficult, Sonam, in a very short span of time. But see, again, I've been telling right from day one to all of you, please go ahead with seminar package. In itself, it is foolproof.
Oh,
And
sir, only 2-3 things that we require to mention in the paper or in the thesis, like CVPAT or Q square, only those required
okay,
things,
okay.
not the whole
See,
thing.
first,
Only the required thing that you taught us.
see, to answer you, Sonam, uh, just focus on reflective measurement model. Reflective measure. Okay, we can draw it. Okay. I can understand what she's saying. Okay. So let's begin. We have some time. Let's help Sonam.
So
Okay.
you can share the
So
screen.
screen is not visible. Okay, let me share the screen. So yeah, Sonam, that is a good question. I must appreciate you. So Sonam, what's in nutshell that what all she can report in her PhD thesis and all. Sonam, just pay attention. So we started with seminar package. Yes, seminar package. Okay. And when you talk about seminar package, we are performing PLS SEM. PLS SEM in seminar package. Now, let's assume you are working with reflective constructs. Let's assume we are working with reflective constructs. Sometimes there is also formative constructs. Formative constructs. So it's very common that reflective, again, we first step we have to create the measurement model. Steps are simple. Then here again we talked about structural model. Structural model. Yes. Okay. Then third is just report measurement model, structural model, and after reporting structural model, please talk about PLSpredict. PLSpredict. Okay. And PLSpredict will give you this RMSE and MAE values. MAE values. And fourth, if your goal is to compare model, then you can go for model comparison. And here you need to use all this BIC or CVPAT. Now, please note that this CVPAT is there in CSEM package, not in seminar package. Sonam. Yes, okay. And when you go for your PhD thesis, definitely, Sonam, you also go for mediation testing, mediation, and either mediation or moderation. People don't take two, but again, we have also learned moderation, and moderation again we also saw MGA, multi-group analysis. Okay, and coming to your formative construct, Sonam, again here we for convergent validity we do redundancy analysis to establish convergent validity. We do redundancy analysis. And everything can be handled in this particular seminar package, Sonam. Sonam, you're talking about flowchart, not what has been taught to you. Yes?
Sir, actually, this is also what I'm asking. And the second thing is, what I was asking is, can you please, take us through the steps that we need to follow while we running the analysis? Like, first we need to draw the measurement model, then we have to bootstrap, or then we have to structure model, wo wali cheez, so that we can have a, first an idea, कि how, what steps we need to follow while we are running a model. आइदर इन आप सेमिनार नार का बता दीजिए सिंपली, क्योंकि हमने उसी पे काम किया है, तो जब हम अपनी तरफ से काम करेंगे तो हमें एक आइडिया रहेगा कि ये स्टेप्स हैं हमारे पास.
Okay. I think okay. So see, so now actually I did talk about it. See, whenever see, let's say seminar package. Can you see the screen? No? Yes.
Yes, sir. Yes.
So first you should always specify the model. When I say specify the model means you should draw the model. Draw the model on piece of paper or maybe somewhere. Wherever. Yes. Then when we use seminar package, yes. First, what is the first step? We install the seminar package, then we load it into the library. Install.packages, seminar, library packages. And after that, Sonam, if you remember, we create measurement model. We create measurement model. Then we create structural model. Then we create structural model. Third, we estimate the model. We estimate the model. Yes, okay. After that, we summarize the model. We summarize the model. After summarizing the model, we bootstrap the model. We bootstrap the model. We post bootstrapping of model, Sonam. What we do? Once model is bootstrap, we'll get the confidence interval, p value, t value, everything will get it. So after bootstrapping the model, next step is what we do. We calculate the predictive power of the model. Predictive power of the model. And here we use PLSpredict. Here we use PLSpredict, or for that matter, Q square. Now please note that Q square you will get in CSEM package. In for PhD thesis, you can combine seminar with CSEM, no problem about it. And this PLSpredict, it is there in both CSEM as well as seminar. Okay, just remember this predictive power of the model. And after predictive power of the model, we go for model comparison. We go for model comparison, but model comparison is necessarily not the goal of many researcher. And of course, then mediation, moderation is there. Mediation and moderation testing is there. By the way, mediation and moderation you specify in the measurement model itself. So this is part of step 4. Step 4, that is structural model. Specify create the structural model. So when you create the structural model, there itself you give the command whether you want mediation or moderation. So Sonam, it is simple. And Sonam, again to answer you, Sonam, you should to answer you in a very specific way, Sonam. आप एक काम करो कि ये जो है ना सोनम, ये जो मैंने पहला सिंटेक्स आपसे शेयर किया था ना, जस्ट अ सेकंड, मेरा डेस्कटॉप कहाँ पर है?
Okay, day 1 वाला syntax.
हाँ
These all steps are written there. Okay,
हाँ, तो उसमें मैंने सारे स्टेप्स लिख दिए, देखो कैसे क्या करना है।
okay.
इसको मैंने बहुत छोटे तरीके से समझा है, देखो ये छोटा सा। तो देखो यहाँ पे लिखा है स्टेप 1 स्पेसिफाई द मेजरमेंट मॉडल, स्टेप 2 स्पेसिफाई द स्ट्रक्चरल मॉडल, स्टेप 3 एस्टिमेट द मॉडल, summarize the model. Can you see? Everything is written here.
Yes, sir. Yes, sir. Got
Then
it.
check the validity. कैसे validity check? Bootstrap the model, then plot the model. All those things. So it's mechanical, Sonam. It's mechanical. It's very mechanical. But still, if you have doubt, you can reach out to me. We'll help you. Don't worry about it.
Sir, it's clear. It's clear to me now. Thank you so much.
Yeah.
Sir, can you please save that file, like where you written about the CSEM and seminar wala जो भी किया था?
I'll send you this file. No, this we can't save it, but I'll
No,
definitely.
not this one. This one is I can refer to वो day 1 ये वाला.
हाँ, ये मैं आपको दे दूंगा. Don't worry. ये मैं आपको send कर दूंगा.
ठीक है, sir. Thank you so much, sir.
Okay. Any other query? Any other query anybody has? So tomorrow we'll go with all model robustness checks in R, and tomorrow will be a hectic day. By the way, I'm sure that many of you would be facing difficulty when I was running that complex model. So complex model again, running is also very complex, but you have to go slow and you really have to practice. The complex model that you see, it is for my paper, and for many days I at least do 10-15 days I spend behind analysis, and then I develop theory around it. So it takes a lot of time to write a complex model code and generate output. It takes time. Okay, but don't worry. Once you start practicing it, then R will become very, very easy for you. The only thing is that you need to take a practice, that you need to practice and go start using it. Okay. So any other query that you have, or should we call the day? It's close to 9:30. Go ahead, go ahead.
सर
हाँ.
चैट जीपीटी नहीं लिख देगा कोड हमारे अगर हम उसको डायरेक्शंस दे
लिखता है,
दें?
लिखता है, लेकिन पूरा अच्छे से नहीं लिखता है. जैसे मैं भी ट्राई कर रहा था सुबह सीवी पैट के लिए. मैं
ओके,
आपको दिखाता हूँ. जैसे कि मैं चैट जीपीटी लिखता है, सोनम लिखता है चैट जीपीटी. यस.
एटलीस्ट इट कैन गिव एन आइडिया ना, तो हम करेक्शंस तो फिर भी कर सकते हैं अगर थोड़ा बहुत
Yes.
आइडिया दे दे तो
So
उसको.
let me use Capilot. Just let me do this. R. Let me use this Capilot, and let's say R syntax for PLS SCM. Let me see if it gives. लेकिन कस्टमाइज आप ही को करना पड़ेगा. It is you has to customize. See, install packages, seminar. See, it is talking about seminar. See, can you see, Sonam?
यस सर, यस सर.
ये सब पूरा वही स्टेप बता रहा है. Create your measurement
Yes.
model, reflective model. Yes.
I have seen in one workshop ना, they are creating the commands for Excel, like उसमें micro VLOOK, XLOOK, तो उसकी बिल्कुल perfect दे रहा था वो ना, तो I thought कि आर की भी दे ही देगा ये.
दे सकता है. चैट जीपीटी में ट्राई मारो, मिलेगा आपको. बट मेरे हिसाब से ना विग्नेट में ही सब कुछ दिया हुआ है. जरूरत नहीं है चैट जीपीटी का. फॉर
Okay.
सेमिनार एंड सीसेम एवरीथिंग इज देयर इन द विग्नेट. You need not depend upon chat GPT itself, because chat GPT anyway give you syntax. वो syntax को modify करना पड़ेगा आपको अपने डेटा फाइल के हिसाब से. Yes. तो आपको टाइम तो लगेगा ही. So it's always better कि वो विग्नेट में जाओ, पूरा कोड उठा के कॉपी करो स्क्रिप्ट में and change it according to your data file and see it makes sense to you. By the way, whatever syntax that I've given you, friends, I have written on my own, borrowing from multiple sources. Multiple sources. ये काफी टाइम लगता है सब syntax लिखने में, बहुत टाइम लगता है. थोड़ा भी एक कॉमा का मिस्टेक हो गया, कैपिटल स्मॉल हो गया, कोई ब्रैकेट मिस हो गया, it creates lot of problem. But
So,
be patient.
Sir, and how do you, like in SPSS, we have a separate output file, which we can access anytime without opening the data file. So how do we do that in R?
R में क्या है? Save the syntax. Just save it. Now see, let me close this R, Kiran. I have saved everything.
How to save the console part?
See, I'll show you. See this, can you see this DRS, R history, R data? Just click it.
Okay.
बट सी मैं किरण मैं क्या बोलता हूँ मालूम है क्या कि अपना वर्ड पे लेते चलो उसको. आर में कमांड है सिंक कमांड, सिंक.
ओके.
वो सिंक कमांड से पूरा आपका आर का पूरा फाइल बाहर आ जाएगा. ओके, मैं किरण का एक सवाल लेता हूँ. किरण देखो सिंटेक्स 1 है, सिंटेक्स 1. देखो ये कमांड है, ये कमांड एक्सपोर्टिंग द बूटस्ट्रैप रिजल्ट टू CSV फाइल. It is there in syntax file. If you type this command, no, ये दोनों command, so all your R output will go to Excel file in the directory.
Okay.
So it's very simple. Like sync command is sync. All your R work will be taken in Word file or Excel file.
Okay. This will be better. This will be better, sir, because
normally what I do मालूम है क्या कि I get the output, copy it and put it in Excel manually.
Okay.
Let's say I get all the HTML, I simply copy and put it in Excel. और data tab में जाके आगे पीछे करके I put it in column and save it. I'll show you Kiran this way. See, this is my new research, and research 2. So here you'll see this final analysis file. I've created this file and no, this is not file. Just a second. I take an Excel file and analysis. See, I just copy simply a measurement model, everything. Yes. Structural model. I take in Excel file and just cut copy and put it in the manuscript. Yes. Okay.
Yes,
Syntax.
so in case the reviewer asks for sharing the data file or output of the software, then we can share this manually.
Share the syntax. Share the file. Yes.
Okay. Okay, sir.
Okay. Any other query? Okay. Come on. Any other query? By the way, 10 people are there. I'm happy. By the way, Abhishek, have you understood? Aditya, what is your feedback? Have you understood? Dipali, Gopi, Priyanka, Hemant. today's day was hectic. Let me admit, today's day was hectic because the syntax were very complicated, and I didn't go behind explaining syntax. If I had gone behind explaining syntax, we wouldn't have understood anything. But the thing is that everything is shared with you. Go and practice now. Go and practice. Things will become crystal clear for you. Okay. And even after this workshop, we'll have a good working relationship, and we'll take our bonding ahead. Let's publish some papers. Let take our view on something. Or yes, okay. Now, even if your institute, maybe you require some resource person, and I'm ready to travel by sleeper class, and so I'll come to our institute, and maybe you can conduct an FDP 5 days, 6 days at your institute, and you can get money for your institute. You can charge 5,000, 6,000 bucks for from the participants, whatever it may be, 3,000, 2,000, whatever it may be. I'm ready to travel by sleeper class. You can organize one FDP for North India, South India, whatever it is, and I'll come and I'll teach them. And physical is always a fun. So when I teach physically, you'll see altogether a very different kind of teaching happens. In online, you are very restricted, and you have to sit at one place, and you have to listen only. But offline is always better. You get interaction, you get a lot of knowledge and all those things. So plan something at your institution and let me know. And so definitely I'll be happy to come to your institute and train a lot of faculty members. Be faculty from any place. We'll definitely do a good job for them. Okay. So practice. So one last query we'll take, and then we'll wind up the session. It's almost now 9:35. Any other query? Okay, so tomorrow will be the last day, and we'll have a group photo, and we'll call off the day. Tomorrow we'll focus on model robustness checks. Okay. So thank you so much. Recording will get very soon. Thank you so much. Have a nice day. Great.
Thank you, sir.
Thank you, sir.
Bye.
Yes, sir. Yes, sir.
Thank you, sir.
Bye. Bye.
Thank you, sir.